ability to do your own design. That can mean combining already existing elements into your own design, or it could mean drawing, sketching, creating 2D and 3D objects in design software. To me, it's a very compelling part of it. The other piece, especially for folks that are involved in professional replication of their work for sale, or involved in toy drives or other things where there's a lot of product that needs to be reproduced, and hopefully with a certain amount of reproducibility, CNC machines are really helpful for that. You can cut multiple things at the same time. You can load different pieces of material on and load them and cut them identically over time. We'll talk about the particulars of all of that in a little while. But for replicating work, it's a real productivity enhancer. So why, as I said, and you'll see, wide variety of applications for CNC machines. That's why I describe it as the most versatile thing. That design software opening up the possibilities for you to be creative, do your own designs, and repeatability and enhanced productivity. How we doing? So far, so good? Oh, dang. All right. This is a bit of an eye chart, but I found this diagram on the internet, and I really liked it. It's a little hard to see in the back of the room, I understand. What it's showing is what is process workflow in a wood shop. It starts with lumber. There's initial stock breakdown, chop saw. If there's sheet goods involved, there's a panel saw. You prep it, you make it S4S, you get it ready to go. Table saw, jointer, planer, you come around, you sand the thing, and then you get into shaping and joinery. And here, traditionally, is where a router table or a table saw begins to come in to help put the work together. Band saws, table saws, drill presses, workbenches, and here's the handheld router that's helping in the shaping and joinery process. You sand it, you might turn some stuff on a lathe, and then there's the artistic part, ornamentation, scroll saws, veneer stations, hand carving, and then finish, assembly, glue up, prep, and so forth. Cool, right? So here's the places where the diagram highlights routers. And most of you, I imagine, have used routers in the past, right? You kind of guide them around, or you create your own templates and jigs, and you might get fancy with plunge routing and all that. So those are the two places where it goes. I suggest, however, all of these places are places where CNC routing has an opportunity to add value to woodworking. You can't see that, but you can see this. So this is a list of all the places where I have found, and we will be able to demonstrate where value for a CNC router comes in. There was a member of the guild who will remain nameless, but he's a carver. And what he said was, CNC, it's just for routing. It's not true. If you've got a 4x8 sheet of plywood and you happen to have a CNC machine with a large enough bed to lay that plywood down, it'll cut out whatever you want cut out. So it's a saw. It could replace the panel saw that's out in the shop right now, but we're not going to talk about that at the moment. If you need to surface plane, I wouldn't surface plane a 4x8 sheet of plywood on that thing. It'll take quite a while, but there's some very precise routing and joinery operations that you might want to do on your machine, and you can surface plane a piece of material on it and make sure that it's absolutely parallel to the bed. Very handy for doing that kind of work. And one of the first things that you'll do with a surface planer is to make sure that your spoil board is flat and level as well. Shaping and joining, there's all kinds of ways that you can use CNC machines to do this. And one of the more sophisticated ways, believe it or not, is to cut dovetails. And Vince has created a gadget, which is a fancy word for a plugin that goes into VCarve that will actually allow you to create a wide variety of dovetail joints. It's an astounding little piece of software. And for me, who's a novice woodworker, it's going to save a lot of time when I want to make my dovetails. Drilling is a piece of cake. You stick a drill-like bit in that thing and let her go to town. Those of you that have ever tried to make cribbage boards, 200 and some odd holes, you can tell me about jigs and templates and how fast and easy it is, but all you have to do is put your piece of material down, put in your program, and watch for a half an hour, and your hole will be drilled perfectly reproducible, perfectly spaced. Sure, you can use it as a regular router. Those of you that have done plunge routing know what the Z-axis is all about. We're going to talk about X, Y, and Z in a little while. And if you get a schmancy machine like some of these guys have with a rotary axis will hold a piece of material longitudinally and turn it while the carving bit comes down and operates on it. And you can create amazing things, lathe-like turning that you can do on a CNC machine. We have some examples of that work that we'll show later on. Ornamentation is where CNC routers are most commonly known. If you were to say, what's the most common application of CNC machine? Probably sign making, plaques, trophies, things of this nature. I don't mean to demean it. There's thousands of opportunities to use CNC for that. And you can get into schmancy carving. We'll see some of Tracy Ann's work in a little while. Carving that she does is just spectacular. So relatively simple ornamentation or really complex stuff. And you'll see examples of texturing. I had the opportunity to take Michael Cullen's class where we did bandsaw boxes. And one of the things we learned was how to do texturing with hand carving. It's a skill. I loved it. It's enjoyable technique. But there's also tool paths available for you on the CNC machine that will kind of do what his stuff does. Okay. Questions before I move on? Any questions in the peanut gallery out there in Zoom land?
Nope.
Moving on. Yes, sir.
So this means that we can get rid of our table saw and our router table.
I don't think I'd go quite that far. Although I tell you, when I first got I got into woodworking being inspired by CNC machine. What I want to do is Japanese joinery on a CNC machine, right? Nothing like jumping in the deep end of the pool. And I said, you know, I could go down to Rockler or Woodcraft and I can get S4S and I can just slap it on the machine and carve away. And you know, I can't. I don't want to anymore because I've discovered what the soul of real wood is about. And I love the process of taking it, chopping it and planing it and sanding it and all that stuff. But nonetheless, if you wanted to, you could do the lion's share of your woodworking just on a CNC machine if you started with S4S, right?
Actually, I threw that out because I thought when I got my CNC machine, that one, I was going to be able to get rid of my router table. A lot of my other tools, I have used my router table way more with projects that come off of the CNC. Yeah, it can do it, but it's so much quicker to do cut out on a table saw.
Yep.
Those my chisels that I never was able to use, but now I use. So I've used all of my other tools way more since I got my CNC.
Yeah. Cool.
And use the right tool for the right.
That's right. That's right. And experience tells you over time what's the best tool to use.
Yeah.
Okay, some of the benefits of using the machine. This is a point that Dave had made when we were putting the presentation together.
Hey,
You can
Rich.
take your piece of material,
Rich,
put it on the bed, clamp it down or hold down the workpiece. Yes,
Rich, when you have a question there in the audience, would you please repeat it so that everybody can hear it in Zoom?
yes, I will repeat the question. What is the question? Because I can barely hear them.
No, he wanted you to repeat
Got it. Okay. So what Craig had asked was, can I get rid of all the rest of my power tools in my shop because I've got a CNC machine that can do virtually everything? And the answer was, well, maybe not quite. So that was the short answer to that question. So in one setup, for instance, the example that I'm using here is making an elliptical cribbage board. So you start with a rectangular piece of stock, clamp it down to the machine, put in your tool paths. You can cut your fancy engraving. You can drill all your holes. You can cut the elliptical piece out of that rectangular piece of material and do it without ever changing your setup. It's different tool paths. We'll learn what those are if you're not familiar with tool paths. It's different bits probably to do those different operations. But nonetheless, There's no walking around the shop. There's no setting up a bunch of different tools. There's no repositioning and alignment. And are the holes going to be in the right place compared to where the engraving is? All of that stuff is set up once and done. So the ability to implement your design, multifaceted designs in one go is, I think, is a huge improvement. Looking at it the other way, you can also say if you happen to need to build, let's say 200 rail pails, if you're remodeling your house, man, doing that by hand, it'd be a lot of work. But if you could bang them out 4 at a time, 15 minutes at a go, that's a huge productivity enhancer. And we'll show that Mark has done exactly that. So you can make 100 all the same. So the repeatability is important, especially if you've got an assembly with multiple components that need to come together. You know, back in the old days when they made guns, all the pieces were individually made, right? And then Eli Whitney and some other guys said, hey, if we get really smart, we can make interchangeable parts. And you take a piece of A and a piece of B and a piece of C, and you know they're all going to fit together. And boy, was that a big manufacturing productivity enhancer. You can do the same thing with CNC. You can cut a half a dozen mortises and a half a dozen tenons, and those things are all going to fit together. There's very little hand tweaking once you get the process down. And Vince is one of those guys that will show us he's got that process down. The precision and accuracy of these machines, once you've got your machine set up and aligned, is better than the stability of the material you're working with. So when we talk about alignment in the machine, we're talking about mils. When you're talking about stability of the woods, you're at least talking about hundredths. So we've got 10 times more accuracy in what we can do on the machine than the stability of the material you're working with. And that, in conjunction with the repeatability, means things are going to work the way you want when they need to come together. And for me, I said, you know, I'm interested in doing Japanese joinery. Well, you know, I don't have 40 years to learn Japanese joinery really well, so I'm going to cheat. And yes, I'm a bicyclist and I ride an e-bike, and I think that's cheating too, but it's good cheating because it allows me to ride rides that I used to be able to ride that I can't ride anymore. And I'm going to be able to do things with my CNC machine that would take me years to learn how to do if I tried to develop the hand techniques. And like I said, I just don't have that much time anymore. Questions about this slide? Is this resonating with anybody? You getting, yes, sir.
How sharp is that inside corner?
The question is, how sharp of an inside corner can a CNC machine make? Part of that's dependent on the bit. Yes, part of that's dependent on the bit that you use. And the sharpest corner that you will get is a function of the radius of the cutting bit that you use. If you want it to be perfect, well, I don't know, so this corner square, or they got a little radius in it. It's from the slab table class. We've got, Zoom guys, we got a piece of material here we're going to take a look at.
That's the pattern.
And that's the pattern. We could do that. We can do that. So you've got radius in the corners, even the tight radius in the corners. That looks like, I don't know, like 1/8 of an inch or 1/16 of an inch radius. We got bits that we use typically that can go down to 1/32 of an inch. So we'd be able to cut that on a CNC machine, I think, without much difficulty. If you really need square corners, you're going to have to take out a chisel. There's just no way around it.
Depends on what you're trying to do. If you're just trying to make a square corner straight down, you're right, you might have to. But if you're trying to take 2 pieces of material and inlay them together, the result, you do it entirely on the CNC, and the result will be a very sharp outside corner.
Yeah. Ah, great, thank you. We've got an example of inlaid cribbage board. Can I hold it up to a camera?
There's pegs in there, so
Okay, be careful with the pegs. There you go. There's your inlaid cribbage board. Right?
So let me mention something.
Please.
This is done using a V-bit, and the very sharp tip of the V-bit gives you those little corners.
Yes.
And if you do that right, you can get sharp corners in many places.
Very good. Almost square, almost, right? There are some tricks, if you didn't have access to some of the fancier tools that you could use on CNC and you wanted to do dovetails or some other joinery, there is relief in those corners sometimes that gets hidden. So you don't necessarily have to have square corners where you might have thought about them otherwise. So I think there's a lot of technique that's evolved in order to help get us closer to that.
Hey, Rich,
Yes, sir.
not a question exactly, but a comment adding into your repeatability. The focus you were talking about is making like 100 parts. But from the design side of CNC, parametric design is fantastic and repeatable, because once you have a rectangle, all you have to do is change the sizes and it can be any rectangle. If you have a threaded screw, all you gotta do is change the pitch, you know, so it's repeatability, you know, like 3D chess.
Yes.
You can make this part. Now I'm talking about the design of the software, right? So once you get comfortable with the software, you can make this library of parts or have a library you started with and expand on it simply and repeatably.
Excellent point. Michael Borgo brings up a great point, which is the repeatability in design work. As an example of that, one of the things that Vince has used and we'll talk about is a program called Cabinet Sense, where you get to lay out cabinets. And what we've learned is that once you lay out one cabinet using what's parametric design, which means it's easily scalable, you can create cabinets with that same basic shape and scale them in any dimension and get repeatability that way. Did I get that right? Okay, so though that was the short answers to the questions, let's dig in a little bit more. First of all, let's talk about the machine. We have a machine right here in front of us. First is the machine. Key components in the machine. You need a bed. This is the bed down here. Hiding underneath this piece of MDF, there's a solid bed that supports the workpiece. On top of that, we put a spoil board. It's called spoil for a reason. You'll dig into it. Everybody does. It's one of the things we do. But it also provides a variety of mechanisms for you to secure your workpiece down to the bed. And we'll talk about how we do that in a little while. Just like you do with a hand router, you move the router around. If you remember your geometry, we've got X, Y, and Z. You can see it marked here on the diagram. Most machines will find an origin at this corner, a corner. X goes that way, Y goes that way, and Z actually starts top and positive Z goes down from 0 up here. The machine, of course, is able to control all 3 of those axes. And at least with the vast majority of the machines are able to perform motion in all 3 axes at the same time. We'll talk about the design implications of that, but that's what it can do. But most machines use stepper motors. These contraptions up here in order to drive the axes. We've got one here for Z, we've got one here for Y, and there's another one hiding in the back for X. Some machines have 2 stepper motors to move the gantry back and forth, and those steppers need to stay in sync just because it's a heavier piece of stuff that they're moving around. And then there's different options for how the stepper motor rotation is translated into the linear motion that we need for X, Y, and Z. You can see belts, rack and pinion, lead screws, a variety of techniques. This machine uses rack and pinion. The gantry is the thing that holds the cutting device. So this is the gantry all across here. This machine uses a router. It's a Bosch router. Higher end machines, we'll talk about spindles and liquid cooled and for production work. But for low to mid-range machines, a router like this, a couple of horsepower router is the typical bit that's running it. And then you need some electronics to control the gizmo. In this case, we've got a small PC that's running the machine control software sitting underneath it. There are some machines, there's that little guy. That's it. It's the whole thing. None of these, the software that we're going to talk about requires particularly high-powered machines. Standard desktop PCs, this little mini PC is all the machine control stuff needs. So I got a little bit more about the machines. I thought I'd mention a word from one of our sponsors. Looking for the Rockler sign, thank you. So this is one of the CNC machines that's offered by Rockler. The brand name is Axiom. This one has a 24 by 48, as you can see, bed with 6 inches of Z. That's typically about what you get, 6, 8 inches, something like that. There's usually not a heck of a lot of Z. It's a higher end spindle. You can see it's liquid cooled. It doesn't require a little PC. They've got a little embedded dedicated computer that runs the machine. They use ball screws, which is typical for a mid-range machine. These magnetic proximity switches are things that are installed in the machine here at the terminus of the motion of the machine. It's so that if you're running the machine, it doesn't slam into the end. The proximity switches should tell the software, hey, man, you're at the end of the line, stop moving.
Would that happen if you program it, like you scale it off?
You can, you will, but you'll miss, it'll bump.
Put in distances of 3 inches and then vertically put in 30, for example.
Yes.
You'll try to drive the machine off the gantry, but the switch stops it.
You can, but yes, yes, the gantry isn't going to fly off the machine. There are physical hard stops there too. It's a little jarring when the machine hits the hard stop, and at least my machine has been pretty resilient to those kinds of experiences. I haven't had any problems with it since. Yeah.
You said that it was liquid cooled. What components are being cooled, like the bit or the motor?
Yeah, it's the spindle itself. It's the motor that's in here. When they get, what's a typical spindle? 5 horse, something like that?
3 horse, 12 horse.
There you go. So, oh yeah. So the question is, what is being liquid cooled? And it's the engine, the motor that is driving the bit. That's where the energy is, and that's the part that gets hot. The routers, they are basically air cooled, so we don't even really think about it so much. But for the higher powered machines, especially ones that are going to be running long periods of time, and there's other advantages to liquid cooled spindles, but that's what's being cooled.
Does it translate to the cooling the bit as well? Like
I don't know.
It's
No,
not designed for that.
no, you can still burn the bits. Pardon me? Water, my knowledge.
It's typically half water and half antifreeze.
There you go. That would be
Okay.
mine.
All right.
Just to
Okay.
make it easier.
Yep. So the question was, what is it that's cooling it? And it's a mix of water and glycol.
Just kind of a follow-up. Is there anything in the software to keep you from burning wood?
Is there anything in software to keep you from burning wood? And the answer is no. There's not. Well, there's. It's like the pirate code. There's guidelines.
Okay.
But there's nothing absolute. If you want to burn wood with this thing, trust me,
I've started a fire.
you can. Yeah. It's usually inadvertent. There's better ways to start fires.
You meant to avoid burning.
That was kind of.
There you go. Right. A better.
And you can control the feed speed so that you're not going too fast or not going too deep, just like we do in the shop here. You know, if you have to take a third or a half of the bite first to remove some material and come back again.
Right.
I thought with the computer involved, you could put the wood in, you could put the depth of cuts already in there. That's probably, you should be able to just push the button and go, baby.
That's pretty close. Can you just program the thing and push the button and it goes?
No.
Not exactly. No, not exactly. Yeah. Yeah.
But there is a tool database, and the tool database for each tool gives guidelines on how to use it.
Yes, good summary of that. So in the world of speeds and feeds, which is a topic that we'll touch on here, that's where the burn prevention part comes in. And there's a tool database both in the design software and in the CAM software, the machine software, that will that offers recommendations on how fast it should turn, how fast you should feed in order to get the optimum cut.
And similarly, a materials database about speeds for whether it be aluminum or brass or acrylic or wood or.
Correct. And those speeds and feeds, as Michael points out, are dependent upon the material you're cutting as well. Even hardwood, softwood, there's variations, right? Okay. So the machine that we're still talking about here has T-track for its table. You can see the T-track down here. Very handy for clamping down material, optional stand and storage, and it's an $8,500 machine, which is kind of a mid-range price for some of these guys. Craig mentioned that there's a new machine on the way. This is a picture of what that is. It's got a 3x5 foot bed, so it won't handle a whole sheet of plywood, but it'll certainly handle some sheet goods. It's a beast. These legacy machines are really solidly constructed, all steel. The one that we're getting does have a rotary axis, has the rotary axis, does have a spindle, not a router, and something that's particularly near and dear to my heart, which is vertical work holding. What the heck is that? If we were to look at the bed of this machine and you laid a piece of material down, chances are good you're going to be laying it down on the bed, right? And then you can carve into it this way. Well, what if you want to do a dovetail? Well, now you got to carve into the end of the board. So how do you do that? You have a vertical work holding system here that will hold your piece of material like that. I'm holding my hand vertically for those that can't see it at the end of the workpiece. And now the bit can go back and forth and cut pins and tails and do all kinds of other things. So for a guy that's interested in Japanese joinery, vertical work holding is essential.
3D sculpture will
And 3D sculpture will work better as well. That's right. So not an insignificantly cheap machine is a $17,000 machine that we ought to be getting for under a couple of grand. This thing is awesome. On the slightly other end of the spectrum, but one of the more popular, let's call them hobbyist machines, are the Shapeco. At least somebody one person in the class has one. They're on the Zoom call, who cares? But there are Shapeco machines around, and not quite as high, and you can see the $1,700 price. They use belts to drive the mechanism as opposed to lead screws or rack and pinion. They have embedded electronics. They also have free software that comes with it, design software and machine control software. So as a way of getting in and experiencing it, this is one of the better, certainly one of the better quality machines at the price. And there's a huge community of people that use these things. So you can find forums and other support stuff online. Not a bad way to go if $1,700 is what you feel comfortable spending.
And Bill Cogswell on Zoom admitted having.
Bill Cogswell, he's the guy. And you'll see some of the work that he's done on this machine. So you'll get a feel for that. How do you decide what you need? Well, there's a lot of different factors. You're a pro, you're going to use this in professional work. You're going to want something pretty reliable because when the deadline comes and the router motor burnt out because you used it too much, that's going to be a problem. So maybe a spindle will give you more of the reliability that you're looking for. The precision and accuracy is going to be more important for the kind of fine work that Tracy does when she's carving for the joinery work and so forth. But if you're going to be carving some letters on a sign and a plaque and stuff like that, you don't need to get it down to mils. The bed size, as we talked about, is really important. If you use sheet goods, you're going to want a big bed, no question about it. But if you're doing boxes and signs and ornamentation, I haven't yet reached the limits on my 2x2 bed that I've got on my machine. I'm perfectly happy with that for the time being. We talked a little bit about routers and spindles. Routers on the lower end, spindles on the high end. Spindles certainly for production work, but routers will certainly get you by if you're a hobbyist kind of woodworker doing it. I haven't had any problems with mine.
You said some
So-
machines can be router based and can be upgraded to spindles.
Yes. Yes. So the question is, can you upgrade from a router to a spindle machine? Many of them can be, yes. So my machine, for instance, I've got an Avid CNC that we'll talk about in a minute. Comes with a router mount, but I could buy the spindle mount and the spindle and put that in as well. Tracy?
And one other consideration is the noise. The router is much louder.
Yes, thank you. Yes, Tracy Ann highlights the fact that routers are considerably noisier than spindles when they're cutting. True that. And you're going to want to be around the machine when it's cutting. So noise is a factor. Dust collection is too. You'll have dust collection running when the machine is running as well. Or a shroud, or both. Yeah. And a point that Dave makes on a regular basis now that he's stuck with a router-based machine instead of the spindle thing he's used to is he's got to turn the thing on and off by himself, as opposed to the controller turning the spindle on and off. And also, typically the controller, if there's a spindle, will control the speed. So in speeds and feeds, the speed is set. I got to turn the dial on my router in order to change that. What do you want for a work surface? Everybody's got to have some kind of a spoil board. I have found that T-track is a very common option on the machines. You get to use clamps and stuff like that. Although a lot of the work holding that I've done, I've been using double-sided sticky tape. Works just fine. Tracy Ann uses blue painter's tape and CA and accelerant. Works for her. So we'll talk a little bit more about work holding, but thinking about what kind of material you're going to have and how are you going to hold that sucker down is something to consider. Vertical work holding, we meant, yes, Craig?
I just wanted to make a point that one of the scariest things that happens on the CNC, and probably everybody will see it happen at some point, is if your piece comes loose. Yeah, it is so scary when you've got a router turning at 15, 20,000 RPM. You know, the hole that you're going to make is supposed to be a ½ inch and it ends up being, it just is one of the scariest things.
Yes.
So it's a really critical.
Yeah.
Is hold it down solid.
Hold it down.
Dave uses screws.
Yes. Yeah, we'll talk about the different hold down techniques, a variety of them. And the other thing that we could point out on this machine, as many of the machines that I know have them, I certainly know where my emergency stop button is. And I'm glad that I knew where it was instinctively when I had to hit it. If you're way on the high end in terms of production, as we mentioned, a number of projects will require multiple tool paths and multiple tool bits. We have to take out a wrench, and you know how it is to change a bit, collets and all that stuff in your router. You're going to have to do that on a machine like this, unless you get one of the fancy automatic tool changes where you lay out a half a dozen bits and the machine just goes over and drops off the old one and picks up the new one and automatically aligns it and positions itself so it knows where it is and off it goes by itself. If any of you get that machine, invite us all over to use it. Rotary axis, we also mentioned, if you're interested in turning, but you don't have any lathe, great for making legs, canes, as we'll see, any type of material that you would typically imagine cutting on lathes. You could do a bowl, although I'm not sure I'd recommend it.
You can do a statue.
You can do a statue, correct, right. So you can get true 3D. If you wanted to do chest parts, as an example, rotary machine would be a nice way to do your pawns and bishops. Do them all.
You can actually do the knife by doing one side and then rotating 180 degrees doing the other side.
Nice. Yeah. Yeah, that was good. That's worth repeating. As I mentioned, doing chess pieces on rotary, and I said there's a couple of those round pieces that you could do. Dave highlights the fact that you can actually do all of them on rotary, where you'd cut one side, the top side of it, and then flip it over and cut the other side. And of course, the seam will be virtually indistinguishable.
If you're smart enough, you'll reverse your artwork too.
Dave suggests reversing the artwork will also make sure that it matches properly. While we're talking about rotary axis, so there's the 4 axes, as the rotary axis is often called the 4th axis. Craig and Smith and Jones had the opportunity to go down and see the Pilot Pro, and I looked at their YouTube video, and it has a 5th axis. And the 5th axis is the Z axis. The cutting machine can rotate this way. So one of the things that you can't do easily with CNC is undercuts. Right? How do you get that bit under there? If you've got a wide bit, like a dovetail bit, you can get in there a little bit. A keyhole bit can get in there a little bit, but if you really want to do undercuts, it's a pain in the patoot. But if you had a machine that could turn that bit sideways and get in there, baby, now we're talking. And watching that thing spin around it's a cool video. Anyway, Pilot Pro made in St. Helens. Other thing to consider, of course, with all this, you're going to use your own machine or do you want to use the shop's machine? Shop's machine has certain advantages, like it's free. Well, the shop card and shop time, it's virtually free, certainly compared to buying a machine. The biggest issue, the biggest limitation I think that we'll find as people want to use the machine is some of these projects have long cut times. Tracy's got stuff that goes for multiple days of cutting to get the level of detail. Pardon me? A full week, she says.
That's with me turning it off at night.
Yes. Yeah. So Tracy will go into the shop, run the thing for 8 hours and shut it off, come back in the morning, start it back up again, keep it going. I'm not sure we're going to have the ability to do that here in the shop. So if that's the kind of thing that you're thinking, sorry, Dave, if that's the kind of thing that you're thinking about doing, it's probably best to have your own machine, even if you just got a little machine and put it in your apartment. Right, Dave? You can talk about that later. Okay. Questions about how to decide what you want. I'll give you one more chart to put some of this stuff into perspective. From the low end to the high end, this basically summarizes the stuff that we've talked about. One of the categories of machines that we didn't really talk about earlier is the so-called Chinese machine. They have no brand name. Tracy's got a high-end, what I consider to be a high-end Chinese machine. There's also small machines, $500 to get you in the game. So I don't want to disparage them, but down at if you're going to pay $500 or $1,000 for a machine, you're not going to get the kind of quality and accuracy and repeatability that you'll be able to get on higher end machines. And then in a lot of cases, let your budget be your guide. Questions about routers, CNC router hardware, choosing stuff, things like that. All right, one more slide. Some guys or gals build their own. There's router parts companies. In fact, Avid CNC, the people that made the kit that I assembled, started off, the company's name was Router Parts, and they sold parts. And then they finally said, hey, if you put enough of these things together, you can have a kit. And then we can engineer it so that it'll actually work. Otherwise, if you're a do-it-yourselfer, you got to figure all of that stuff out. There's a lot of stress on the router and the router bit as it's carving, and you want to have a rigid platform to hold that. Otherwise, it ain't going to be so good. So I don't want to discourage you from building your own. And then, of course, there's the electronics that you have to put together. But do-it-yourself is a special class of people. Dave told me that I had a very steep learning curve, and then I'm a special guy because I put together a kit from Avid. And this is a picture of my machine. It came, there's an optional T-track bed that I got that's installed on that. And they call it a benchtop machine. You need a really big benchtop. It's only 2x2 in its working bed, but it's at least 3x3 in terms of its footprint. And there's no way to do vertical work holding without a base. So I got a base and I'm futzing around to figure out how I'm going to use this flexible system in order to do the vertical work holding. We can talk about that later. But that's why I bought a kit. I wanted the experience of putting it together. I wanted to learn how the machine worked, and I built my own electronics. I took a PC, I got a controller card, I got the stepper drivers, I put it all together. I built a box to put it in. I'm a geek. It was fun. And not everybody wants to do that. For the higher end machines, there's no kits. They're all pre-assembled and in a lot of cases pre-aligned, which is a nice thing. The alignment took me a couple of days. I didn't have a lot of experience doing that. I had help from Steve McGowan, but now that it's aligned and it's solid. So anyway, you may save some money building a kit, but I don't know. I didn't count up how much I've spent. It's more than my wife knows.
But did you enjoy yourself?
But Tracy asked, did I enjoy myself? It was a very satisfying project. It wasn't frustrating. I never got to the point where I'm pulling my hair out. It all went together the way it was supposed to. The instruction, the manual was terrific. the most challenging part was I could have gotten electronics from Avid because they $1,500, you can get the whole thing put together and it'll work with the machine. That was too much. And so I decided I was going to use my own. I'm actually using the same controller that Ed Swaken uses. So I had that. It's called an Acorn board from Centroid. And it didn't seem all that hard. The hard part was integrating the hardware and the software. Because Avid has their electronics and all the magic about how it's configured was configured in their software, which I didn't get because I didn't get their electronics. So I had to figure out, how does that touch plate thing work with the Centroid thing? That took a few days, but it was solvable technical problems.
How long was the assembly part of the project?
It took, the question is, how long did it take me to put the machine together? It probably less than a week, 3-4 days, working, 4 or 5 hours a day, something like that. It wasn't killer. It's all extruded aluminum, standards fittings. It all went together very well. I'm very pleased with the machine now that it's working.
At the risk of spending a couple of extra minutes on that, I was with Richard when he first fired it up.
Yes, he was.
We actually did a couple of test cuts and so forth. And it exhibited a strange behavior that was obviously wrong. And we pretty much quickly decided that it was a hardware problem, not a software problem. And Rich dug into the thing, and many people who build their own CNC the first time and don't really understand what it's supposed to be doing would not have gone in and found this. And he found a part that wasn't locked down tightly.
Yeah.
And locked it down, and it's been running solid ever since.
What he says is all true, and I'll show you. We burnt some stuff in the process. The Z-axis gantry came as a completed subassembly that I just needed to bolt in. But behind that is the bearing and the mechanism that goes up and down on the lead screw. It was completely detached from the gantry. So it kind of went up and down, but it flopped up and down. And sometimes it, sometimes, and so I had to find that. And once I found it, I got to screw it back in, and it's been good ever since. So that was a little surprise. Okay. I'm done with hardware. Are there any questions about hardware? Have we beat it to death? Too much? Right amount? Anybody sleeping yet?
So you said this one as it stands is about an $8,000 machine. In that range.
Yeah, it's 6,000 to 7,000. Yeah.
So
It typically comes without the stand. So it's considered a benchtop machine, but Craig obviously ordered the stand to go with it. Actually, the company doesn't make it anymore.
So the question is, what's the value of the machine that we currently have at the Guild? And we're estimating $6,000 to $8,000. Yep.
And his big brother is 20-ish.
Yep. Craig, question?
I was just going to say, the bigger machine that we're getting is in the $17,000 to $20,000.
Yeah. Yeah. 20K. Nice. Yep.
The Legacy actually toyed with turning this into a kit
Ah,
so that they could send it to you as parts and you can assemble it.
okay. Didn't do it.
Now,
Dave's comment is Legacy considered making this machine as a kit so that you could put it together? I don't know. Looks doable. Yes.
just one thing, I know you talked about the price of the machine, and that's a critical piece to the puzzle. But I know that I've been asked innumerable times, what machine should I buy? Somebody comes in. My question to them always is, what are you going to do with the machine? Are you going to make cribbage boards, little bitty things? Are you going to make something bigger? And look at what are you planning on doing with the machine? And one of the worst things for me was buying this machine, and this machine does not have a lot of Z height capability. And I would run into a thing where I wanted to make a fairly tall part, like maybe a 4x4, and carve into it. And I couldn't get it up high enough because you've got the router bit and everything else. And so one of the things, if you're going to look at buying a machine, really scrutinize what you're going to do with it and make sure that you don't hit that wall, because with Legacy, they were incredible about allowing me to trade in. Most everywhere else, good luck. You know,
Right, right.
You put it on the market, maybe be able to sell it.
Right.
But, yeah, hitting that wall is.
Yep. So Craig highlights the fact that if you're going to go buy a machine, make sure you understand what it is that you're going to do with it, and make sure that the capabilities of the machine match your needs. And the issue that Craig ran into was limited Z-axis height. Once you add in, I mean, they'll spec what the height is. They might say 8 inches, but that doesn't include the bit, might not include the collet, might not include some other things. So you got to make sure that you really understand what kind of clearance you're going to get. As an example, what is that bed size? Is the bed size the nominal area? Is the bed, can the gantry actually reach it? Can I have material? So there, if you're going to get out towards the edges of the capabilities of the machine, in particular, you need to understand that. Okay, let's talk software. This is the fun part. So first, I would say there's 3 main components of software that you will use on your CNC work. The first is doing your design. You can draw it, you can create it in a variety of ways. We'll talk about some of the different kinds of software, examples of that software that we're going to use. But this is where you're sitting down at your desk. You got something in mind about what it is that you want to make. And now you have the opportunity to render that in your software. And what you end up with is typically 2-dimensional, 2D drawings of the work that you're going to produce. Well, that's great, but now you got to make it. So now we need something that's going to convert that design, those plans, into instructions that can move that bit around and have it make what it is that you want it to make. And that software is called the CAM software, computer-aided manufacturing. And that software's job is to do just what I described. It basically takes your drawing, could be 2-dimensional, could be 3-dimensional, and turns it into cutting instructions for your machine. Critical piece. The output of that is a script, a program. And the program basically says, take the head and move it down here and move it over here and turn the thing on and cut it over here and go back and forth a few times like that and then drill a hole and you're done. That's kind of the program, the script, if you will. We take that script that comes out of the CAM software and load it into the machine control software. That's the stuff that's running on that little PC that's under the machine right now. And that's the software that will then tell the steppers and the thing and the router and the spindle what to do to make your part. Bing, bang, boom. It's just that simple. Yes,
So
Mark.
that part, like on yours, you didn't buy their brand. That's got all the translation from the CAM, what do they call it?
Yes,
Software.
yes.
But when you build one like yours, you don't use their one that.
That's correct. So Mark said, okay, he was going back to my kit, and I said that I didn't use Avid CNC's electronics. That's true. I didn't use their electronics, nor did I use their machine control software. They use Mach, which is the stuff that runs here, which is, if there's an industry standard, it's Mach. I'm using something from a company called Centroid, Acorn, and they provide the machine control software. And the machine, if you think of if those of you who know computers and say a printer, you got the printer software that takes the document, and then you got the driver that matches that to the specific printer. That layer of stuff, that's the part that was missing for me. How do I match that generic machine control software up to my specific machine? And I had to tease bits and pieces out of little places in order to find it.
You had to write some code to convert your.
The question is, did I have to write some code in order to do it? No, I didn't have to write code. I needed to enter some parameters in the machine control software to tell it about my machine. And one obvious thing is, how big is your machine? I had to tell it, okay, it's 2 by 2. What's your Z-axis clearance? Oh, I had to tell it that also. So that was some of the parameterization that I needed to provide to make the control software sync up with my hardware? Good questions. Mark, you're paying attention. Okay, some are free. Some stuff is bundled with machines. We'll talk about some of that. If there's one slide in this presentation for you to wrap your heads around, this is it. And this is the part of the presentation that I struggled with. How do I give an overview of what this process is like? This slide is the best I've found. So let's go through it a little bit. It's 3 stages. We kind of highlighted them with the 3 different categories of software. In one case, you're going to do your design. Stage 2, you're going to create your tool paths. The 3rd stage, you're actually going to cut your work. The purpose, you can see, you sit down, smoke some dope, get some ideas, render them in software. You don't have to, but render them in software. Stage 1, stage 2, feed that design into the CAM side of the software or a separate piece of CAM software to get those tool paths, those cut instructions created, and then pass that along to the machine to actually get the work done. You can see what the activities are, creating the cut strategy and the control of the machine, and then the different categories of software that you use. This is the basic process for how you do stuff on a CNC machine. All right, I'm going to drop down one more level in terms of design. This is kind of an important part too, but it's a little subtle. So the notion is there's 2D, 2.5D, and 3D design. What the heck is 2.5D? Is this like an Einsteinian thing? No. 2D is when you create a design and all the cut levels, the depth of the cut is all the same. In some cases, like if you were doing engraving, you might actually go all the way through the material and cut it out. That's 2D design.
Sort of like a router without a plug.
Sort of like a router without a plunge. I like that. It's exactly right. And you're done. Super easy to design because all you have to do is 2D design and then just say, just cut that thing. And so creating the tool paths is very simple. What is this 2.5D thing? The 2.5D thing exists because 3D is hard to design. You got to think in 3D. You got to draw in 3D. You have to use 3D design tools like SketchUp or Fusion 360 or AutoCAD or complicated stuff. If you have that interest, if you have that background, if you have that ability, you can create fantastic things. Not everybody does. 2.5D gives you some of the capabilities that you get for 3D, but you get to design it as if it's 2D. So it simplifies the design. We're not cutting 2.5 dimensions. Everything is 3 dimensions, right? The material has thickness. So that's not the issue. The issue is how hard is it to do the design work? And doing design work in 2.5D is a lot easier than doing it in 3D. Although for some things, like this particular example of 3D, if you can see this slide, there's contouring. So this engraving, this cutting of the letters is wrapped onto an undulating 3-dimensional surface. So first you have to use your 3D software to create that undulating surface, maybe not all that hard, and then put some letters on it and tell the software, wrap those letters on top of that undulating surface and go cut it. Not so hard to do. The 2D stuff is a piece of cake though. You just say, I want the letters, 2.5D contour. Use this bit, cut this font, bing, bang, boom, and the software does the rest. So it really does simplify the design. My advice is start with something like this in the world of design, get some experience with that, understand your machine and how it cuts. And if you want to do 3D, it's awesome because it really opens up the world of possibilities. You can make anything then.
Is that 2.5D like your own terminology, or is that accept that's computer?
This is industry standard terminology. The question is, did I make this shit up? No, no, not this thing. I've made other things up, but not, you haven't caught me yet. Yeah, but this, yes, this is industry standard. Some examples of 2D, 2.5D software. Carbide Create is an example. It's the stuff that comes bundled with Shapeco. It comes for free. It supports some other CNC machines as well, but they really focus their connection between the software and the hardware on Shapeco hardware. But if you wanted to download a version of it and check it out, you certainly can. Vectric VCarve. Who uses VCarve here in the shop? VCarve Pro. VCarve. Okay. Yeah, and Aspire. The first thing I learned when I started to get into this, what software is people using. First of all, Vectric is the brand. It's an English company. It's very mature. Their software is in version 11. It's feature rich. It's very stable. It's not impenetrable in terms of learning how to use it. It's really cool. And VCarve and VCarve Pro are very popular. So if you're just getting into all this, take a look at VCarve. And I said it will be or should be free for cutting at the guild. They have a maker program where we as a guild sign up for the program. We then get a few computers that will run their software here. That runs on the machine so you can cut. But any of you will be able to download a version of VCarve for freezies, do your design on it, and then bring your, on a thumb drive, bring your G code in, bring your script in, load it into the machine here, and you can cut it. Cost the guild $100 a year. It's a great deal. So chances are very good we're going to take advantage of that. Chances are good we're going to offer design courses in VCarve. It is one of the pieces of software that's has great utility value.
How is it imported? If you did something in, like, you brought on comments there about Illustrator or Corel or something, how does VCarve import something?
How does VCarve import things? It imports things extraordinarily well. Two-dimensional stuff. There actually is some 3D capability in VCarve, although we'll talk about one model. You can bring in import one three-dimensional model into VCarve Pro in a particular project. In a project, yeah. So it has some. My line?
You can do multiple, import multiple designs into VCarve. Put them in different layers.
Put them in different layers.
And then you can see the different layers in that version. Imports like DXF or Adobe Illustrator.
Yes. Yes.
Standard interface.
Yes. So output of other 2D design packages,
I don't have to relearn what I already know in AutoCAD or Fusion or something else.
Exactly. That's one of the points that I think is really important to make, is that if you have familiarity with 2D packages already, chances are very good that you'll be able to export what it is that you can create in packages that you know and import them into VCarve as an example, use the CAM portion of VCarve, and then be able to cut your work that way. And also combine it with other elements as well.
You keep focusing on that 2D, but there's a great 3D software out there.
Oh, absolutely. Oh, I got
Like AutoCAD and SketchUp and others. I mean,
Like-
yes, they're hard to learn. but
like AutoCAD and SketchUp and others,
yeah.
and Fusion 360.
Fusion 360, yeah.
Exactly.
That kind of
Exactly.
stuff, yeah.
How much is the software?
There's a free version of SketchUp that still works. Fusion 360 pricing, I don't have off the top of my head.
It depends on what you want it to do.
Yeah, that's right. Different.
The pre-maker version, the full-blown thing is about 500 a year.
There you go. Thank you. The SketchUp, the comment was there's a free version, and if you want the pro high-end thing, it's about $500 a year.
300.
300. Pardon me, 300 a year.
500 for Fusion.
500 for Fusion. Thank you.
So here's 7.
Not yet.
For SketchUp.
And VCarve Pro is in the $1,000 range.
Is that what Aspire is?
700. That's right. 700. Thank you. And a one-time fee. That's right. It's not an annual thing. It's a one-time purchase. And then Aspire is in the $2,000 range, just under $2,000. And there's an upgrade program, which I bit on when I went from VCarve Pro to Aspire. And they just charge you for the difference.
And that again's a one-time.
Again, it's a one-time thing.
Although
And-
they come out with new versions. Like, when it goes to
Upgrade to the
11
latest
and-
version. for-
Yeah. Yeah.
How many people can use the software once you buy
It's licensed. It's licensed to you and you have an online account, and any machine with your credentials and the license can log in.
Vectric says that you can load it on three machines, but three of your machines.
Like your desktop, your laptop, and your tablet.
Exactly.
Right. Or desktop, tablet, and this guy, if you have to do a little tweaking while you're at the machine.
I think as a general comment, the notion of paying $1,000 software is not a nice thing. With the free version of which may be the very low version of that. I'm surprised if I spent more than $400 on, and I actually have more.
Huh, okay.
So I really, if I was coming to this cold and I was doing $1,000, I'd love to become cold. And that really isn't necessary.
Right.
I mean, for that, you have some familiarity, not get a simple version of Vectric,
Yes.
and that's probably where you.
Yeah.
You gotta walk before you can run, right?
That's correct.
Any 3D design software, you can get a long way.
Yep.
There's very little.
So the comment is we've been talking about hundreds of dollars and $2,000 for some high-end software. That's not necessarily the case. You can do very capable work for free. Some of the stuff is free. Inkscape, as an example, is a dandy 2D design package. It's open source. So if you're an open source fan, you'll be able to find versions of that stuff for almost everything. Blender, incredibly powerful 3D package. It's free, open source. So we're talking about commercial software, support, community, and all of that, but there's other options as well. Thanks for highlighting that.
Just in that vein, if you don't know SketchUp, we do have a class now. Couple of months to get class in SketchUp. It's excellent. You get a free version. So if that's something that you don't know how to do, and something you're interested in, we don't have a class for you. So
There's a number of features that are in SketchUp that are particularly suitable for woodworkers that you may not find in other packages. You can output a cut plan from SketchUp, which is very handy, as an example.
You have a picture on your screen? I don't know. What happened to your slide? Check your.
It's working on mine.
You have a picture of you with it working on yours, but we don't have a picture of it.
We don't have the
The software company wants you to buy the software.
they would prefer. I bought this one, you know.
Ask comments and shut you down.
It's even a licensed copy of PowerPoint, for crying out loud.
If it's a smartphone, you're listening.
All right.
Check your video output settings.
Okay.
Is your PowerPoint exported?
It was working just a moment ago. Let me check displays.
It's time for a break.
Yeah.
Hey, let's take a 5-minute break.
I don't deal with it.
Yeah, it was getting a little bit squirrely, and then all of a sudden it just quit.
It still sees it. It still thinks it's there. I can pull it out and plug it in, see if that helps. There it goes. There it goes. All right.
I think they stopped making machines when it wasn't popular, or was it too popular?
A little divot in the.
Yeah, wonder how that happened.
Well, you know, really good time.
Yeah.
You know, they make a replacement for this machine, like this level. They
Mm.
stopped making this one, but did they come out with a newer version similar?
I don't remember. I looked, but I don't remember.
Probably something in that price range.
I'd like to think so, but Vince, do you know? Did Maverick come out? Did Legacy come out with another machine? Did Legacy come out with another machine of about this size, or is 3x5 their smallest now?
No, there was an Artie in between. Dave knows about Artie.
Okay.
I just
And-
been up to the Maverick.
And they're still selling it?
They're not making the Artie anymore.
Ah, okay.
Or this one either.
Okay, right.
So then they just abandoned
The low end, apparently. Yeah, yeah.
I used to be a medic, and the defibrillator company, Life Pack, made this Life Pack 3. It was just bomb-proof, like designed for the fire service. You could drop it, it came apart, and it was so good. When they came out with their new model, they would buy up the old models and destroy them to get them off, because they sold something that lasted 23 years and stopped. They realized
Wow.
they made a product that was so good.
Good. Yeah.
So I was wondering how
No,
they
I know.
I stopped making that because it's a one-time purchase and nobody's buying it.
Yeah, yeah.
It's so
Well,
good.
I would, they're probably busy enough making the high-end ones, is my guess. 7:30, so halfway done on time. If I'm gonna hit 9. Dave needs 45 minutes. So that takes us to 8:15. I've got another, if I had another 15 minutes of slides, it's 8:30 and a half an hour for the end. This is gonna work. This is gonna work. It might be a little long, but
So it's really
it won't
not
go
the
to
kind of thing where you can hit a button and just walk away, go watch TV while the machines come away.
nobody does. Nobody does. You never know when shit's gonna happen. You don't have to stare at it, but you learn to listen. And sometimes something goes wrong. It switches tool paths and the program went wrong and, you know? So, because I've asked that
Part comes loose or something.
shit happens. And so, because I've asked that same question of everybody that uses their machines, and I haven't heard of anybody yet that sets it up.
When I look at these, actually, well, I've been married 35 years, and it was before I was married. It was probably Legacy, but it had a spindle, and they had that for a long time.
The 4th axis, yeah. Yeah, that's not a new feature.
Okay, because this was a long time ago. I actually went to the seminar and the whole deal.
Huh,
Because I was a woodworker for a long time. I was a finished carpenter, and their whole thing was like, you can set it to go to the movies, come back. You know, it was about making money. Like,
Yeah,
just making money
yeah.
for you.
right, well, yeah, you don't even, yeah.
But it was way, I mean, this is a long, long time ago. I think laptops, I don't even know if they had laptops then, you know, it's desktop. And it was way beyond, I mean, I didn't even know what a computer was. It seems so far. But it is a, you know, I mean, I'm a traditional woodworker, and so I have my issues with them. But I definitely know there's a place for them.
There's a place, that's right, that's
And
right.
everybody, I mean, if you're a computer guy that wants to have an outlet in woodworking,
Right.
you don't want to learn woodworking, you know, like you talking about Japanese joinery, like in my opinion, and this, I don't.
Have time to get going?
Yeah. I want to hear your opinion. Okay, folks, we'd like to get started again, please.
What do you think of the router that uses the tape?
Oh, yeah.
Handheld CNC.
The
Shaper
Oh,
Origin.
yeah, yeah.
I think that's a fantastic.
But that requires the same kind of software.
Different.
Well,
Yeah.
the difference, middle layer.
I like this concept of somebody coming in, trying to get in the door.
Okay, boys and girls, who can tell me 3 different ways to add stuff to your design? I can tell you 3 ways.
Okay, we're back.
Good.
We're in session. We're in session.
So, how do you do this design stuff? Those of you that are really good at doing design can just sit down and draw. Not everybody is able to do that or do something in a design that they'd be pleased with when they got their results at the end. But it's not that hard. Those of you that have used any kind of drawing package, you know how to draw a rectangle, you collect around the rectangle thing, you stretch it out, and you got a rectangle. It's not so hard, or an ellipse or a circle or any of those objects. You can create all those things, standard drawing, 2D drawing stuff, and do it in your package. You can import stuff. Michael was asking earlier about, can I import stuff? I can import stuff from other 2D or 3D design packages that I might be familiar with and bring them into something like VCarve and play with them some more. But there are tens of thousands of pre-existing designs waiting for you on the internet. Tracy can tell you all about the artwork that she has found, and we'll talk about some of the sources for it. But there's an incredible amount of stuff. Some of it's a little cheesy, but a lot of it's not. There's some really beautiful pieces of work, and we'll see some of, like, for instance, what Tracy has done. So as a source of inspiration or elements for your design, being able to find stuff on the internet is really cool. Third thing is pictures, photos, scans, bitmap images in text speak. And there are tools in a number of these packages. I'll again mention VCarve because I use it and I'm familiar with it. That is able to take a bitmap image and turn it into the vectors that are needed in order to carve them. You can do what's called a raster scan of those images, or you can do some additional processing on them. One of the projects that I'm working on is I took a picture of a bumphead parrotfish underwater. I got a beautiful side shot of a bumphead parrotfish. I want to carve the fish. So the first thing I did was, okay, I bitmap, scan it in. So I did. So I brought it in and I said, do your magic. And it did its magic. I now have my bumphead parrotfish image loaded in 2D. And I looked at it and I said, oh, this isn't what I want. Exactly. So those of you that are into design, I have a texture map of a fish. And if I went and carved it, what it does is it turns the light and dark into varying depths. But the depths don't vary that much. And you don't want them to vary that much because it's the surface basically that you're looking at. So in order for me to accomplish what I want to do, I need to take that texture map and map it onto a 3D model. So I've watched the YouTube videos and you basically carve that image up into bits and pieces and then using 3D tools, inflate them to their proper depth. Hook them all together, push a couple of buttons. How hard can it be? Well,
or you get a model that's already done by someone else.
Exactly.
Put your
Texture map
onto it.
That's right.
You may stretch it and edit it.
That's
And
correct.
it's yours, by the way, because it was available for free or.
As Michael suggests, I might not have to create that 3D model myself. I can go out to the internet, and in fact, I did 3D bumphead parrotfish models. You think there are any? Of course there are. Everything's on the internet. $49.95, and it's built for animation. So if I want to create a cartoon as a way of introducing my piece of artwork, swimming along, baby, I'm in business. I don't want to do that though. Right? I'm telling you.
But there's a lot of libraries of parts out there that are free.
Yes,
that
there are.
Are a starting place, and even if you think of it in the carving world, we have rough outs. They're beyond cutouts, they're somewhat shaped in 3 dimensions, but then you go to carving details and enhancing and refining it. You can think of those as the same thing. These models are not exactly what you want, but someone's gotten you a head start and you can go in and refine it.
That's right. Michael makes 2 points. One is not all the artwork and imports that you want to get, you have to pay for. It's a ton of free stuff that's out there. And the other thing is he compares it to doing rough outs in hand carving, where you've got the beginnings of it and then you get to tweak it yourself, but you've got a pattern of something to start with. Excellent points. So all of those 3 ways, and of course they can all be combined in any project that you work on. Okay, let's talk a little bit about this CAM business. This CAM stuff is, again, the software that's going to convert your design into tool paths. That's partway along the path to giving the instructions to the machine to cut. Those tool passes you can read here are packaged into what's called a G-code script. We're going to talk about G-code and what that means in just a minute. There are some standalone CAM software packages. MeshCAM is one of them. It actually runs on Mac. Most of the stuff, by the way, works on Windows. The design stuff works on Mac and Windows, of course, but a lot of the CAM stuff and Vectric software is Windows only. Although I have it running on, this is my M2, my M1 Mac. I run Parallels. I run a Windows 11 virtual machine, and it runs. I couldn't believe it. And if all that's Greek to you, don't worry. But man, it's getting 2 worlds that are completely opposite of each other and merging them together. It's just don't even like each other. It's awesome. But when it comes to CAM software, most folks don't need to buy their own CAM software because a lot of the CAD stuff that we talked about includes the CAM features. So in VCarve, as an example, you do your design work and then you push the button and it says, okay, I'm going to switch you over to the CAM side. And all the tools for the CAD stuff is over here and all the CAM stuff is over here, and it works the 2 together. All right, so what's this tool path business? This is one of the CNC things you need to kind of wrap your head around. You've got this design. And let's say you have a rectangle. You want to carve the rectangle. How do you want to carve that rectangle? Do you want to remove the insides of that rectangle? Or do you just want to carve the line around the rectangle? Well, hopefully, as you think of your design, you know which one you want to do, but somebody needs to tell the software which one. So what I just described is the difference between a profile going around the outside or creating a pocket, carving out the middle of that rectangle. So you need to be cognizant of when you're creating your design, if you got that rectangle and that's how you want to carve it, at some point, the software is going to say, which one of those things do you want to use? It's not that hard, but that's one example. You want to carve stuff? It's not that hard. You say, I want to use the engrave and VCarve command. You want to drill some holes? Guess which profile you use? Correct. You want to cut some threads on a rotary axis? Yeah, there's a tool path for that. You want to do that Michael Cullen texturing business? Yeah. Do you think there's clip art included in VCarve that has a wide variety of textures, some of which repeat and some of which are one-off? Yes. Can you scale them? Yes. Yes.
Question is on the inlay. There's actually, that's part of the software that will actually do the, I guess in this case, pocket, and then it will also bring the material that will fit that pocket.
Yeah-huh. Yeah-huh. Yep. Yes, like Craig's cribbage board. Question is the inlay thing. Do you get both sides of the inlay? And the answer is yes. Texturing we talked about. And then there's the weird, my fish, right? I want to carve my fish. Profile, pocket, engraving, I don't know. Just hit the 3D button and it'll do it for you. It figures it out. It's really cool. To me, that's the most amazing part of the software. And there's a roughing and a finishing. When we look at some of Tracy's work later, if you've got relief carving that you're doing and it's 1.5 inches thick, that's a lot of material to take away. But she's got a lot of fine detail. You don't want to do the rough cut with that fine detail bit. You want to have 2 tool paths. You want to have a rough cut where let's get all that crap out of the way, and then let's put the fine bit in it and let's do the work. So that's the difference between roughing and finishing. And there's prisms for pointed. You don't want to carve your letters in. You want them to be proud. Prism works. You want to cut moldings. We got examples of that. You want to just chamfer the edges of your work. We got to. So there's your tool paths as examples. Now you're starting to think like CNCers. Okay, speeds and feeds. We talked a little bit about speeds and feeds earlier. So now you've got a design. You're telling the tool path to move around. How fast is that bit moving around, and how fast is it spinning in your spindle or router? There are, as was highlighted, a few different ways to do it. The goal is you want it to cut clean. You want chips, not dust. You want to maintain good tool life. You don't want to burn anything. You don't want to break your bits. You want all that stuff. And how do you do that? As was mentioned, the tool database, it's a database of tools that's in both the design software and in your CAM software. A number of the vendors publish tool databases. Whiteside does, Amana does, and you can import the whole tool base, their whole line of bits for CNC bits, suck them in. And then when you select that 1/4 inch end mill, and that's the bit that you want to cut, and you're going to cut it in hardwood, it will make recommendations to you about what speed to set your router for, what RPMs, and how many inches per minute or millimeters per second is that bit going to go through the wood. If you're doing rough cuts, you can imagine you're going faster. If you're doing detail work, it goes a little slower than that. And if it's overlapping cuts, what's the step over rate? So there's a bunch of speeds and feeds. This isn't a how-to class, but you should be aware that one of the things that you'll need to master, and it takes a little bit of experience in order to do that, but speeds and feeds is one of those things.
The availability of that data that you're talking about in the tool database is a relatively new thing, probably the last 5-7 years. Whereas before, when you started out with CNC, you kind of were on your own to do it, unless you had a mentor who had been there, and he Ron Reed, Precise Bits, gave me a formula that I wanted, material and speed, the bit size and so forth. And I had to plug in all the data for that, and I got down to it. Now, of course, there's tables and databases and things like that. It makes it a lot easier.
They had all that in the 90s in the industrial smart cam and others, but not in the hobbyist homeowner stuff.
Got it. So the comments being made are that setting speeds and feeds have gotten considerably easier over the years. Some of the knowledge that was gained in high-end machines has come down to the more of the hobbyist and semi-pro levels, and the tool databases didn't exist years ago. Now you at least have a starting point other than experience. But still, my experience, which is quite limited, is you want to do a test cut in the material you're actually going to work on to get a feel for how that's going to go. Mark?
When it comes to bit selection, like if you do a design, does the software tell you what bit to use, or you have to say, oh, this bit will do this better than that bit? Great
setup. We're on the next slide. You can never have too many bits in the world of CNC. The software will not tell you what to do. There are some conventions, though. If you're going to be doing V carving of lettering, then you're going to use a V bit shaped like that. If you can see.
The two red ones.
The two red ones, exactly. If you're going to be doing that pocket cutting, chances are you're going to use an end mill. So there are conventions of which bits you're going to use. If you're going to be doing really detailed work, you're going to want tiny little pointed bits like that in order to do the detail work. Now, is that a tapered ball point, or is that a 1/32? Is that a 1/16? Shit, I don't know. You got
An upcutting spiral or
Right, is it an upcut spiral, a downcut spiral, or a compression pit? Well, I don't know, what kind of holes are you cutting? It's not magic, though. There are tables, for lack of a better word, that will suggest what bit that you should be using for a particular application. If you're going to be drilling in, you want an up spiral bit because the up spiral clears the chips out of the hole. On the other hand, it makes a mess out of the bottom if you actually go through. So there you'd want it down. Anyway, so
Like if you're doing
there's some of that.
mask removal for the rough cutting, you have to figure out when you dictate the tool path, if I use too big a diameter of a bit, because I'm taking a lot of material, it might go past.
So if you use too big of a bit when you're doing a rough out, is it going to overstep the boundary? It won't. What it will, the
You
soft.
set the boundary based on the diameter of bit you're using.
No, actually, the software will do that. So before it calculates the path that the bit is going to run, you tell it what bit you're going to use and what the diameter of the bit is. So it won't overstep its bounds. If you use too big of a bit, you might be leaving more material behind for the finish cut than you might if you were using a smaller diameter bit. Exactly, can't get into the tight spots.
And the packages that have both CAD and CAM usually have a simulator that will produce a drawing or a rendering of what you're trying to do.
Next slide. God, you guys are great. It does. It just runs itself. So as Dave mentioned, you get to do a preview. So on the left-hand side is the 2D drawing that Dave did of the sign that we're going to cut tonight. As of a couple of days ago, this was what Dave was telling me he was going to cut tonight.
If there's a mistake, it'll show up on the drawing.
Well, if some mistakes will show up on the 2D thing, you know, if it was misspelled, that would.
Let me give you an example.
If you have some conflicting tool path /
If
Ruh-roh.
if this shape, the D, were too close to that line, which is that, then the bit you're using for cutting the shape won't go in there. And so it'll come up to the edge and stop, and come around the other side and stop, and you'll have some material in there.
But that'll show up.
It'll show up.
Test drawing.
Yep.
You go, okay, that'll change.
Yes, that's correct. That's correct. And then the 3D version, what you see here is a screenshot, but like in other 3D software, you can use your mouse and change the profile, the view that you have of it, so that you can see the edges and whether those letters are proud or relieved. Exactly, spin it all around. And as we'll also mention, the sequence that the tool paths are cut in can sometimes be important. So if
It's not a good idea to cut it out before you do the rest.
it's not a, right, there's a good example. So one of the tool paths that Dave has here cuts it out, cuts the ellipse out of the rectangle. You wouldn't want to do that first.
The computer would let you if you didn't know any better.
Oh, yeah.
Yeah, it would. It just does what you tell it to do, but it's going to try to help you. It will, if you tell, you have to set up the material. So let's say we're 3/4 inch MDF is what we're going to cut on. If you have a tool path that's going to go down an inch, it'll say, you're going to cut through your material here. Do you know what you're doing? Tracy?
Depending on how you have that secured on your table, you may have to put tabs in there so that the center doesn't fly.
Also correct. Tracy points out that even if we cut the material, cut the ellipse out last, if there wasn't anything holding the center part of the material down, it's going to fly off. And that would be an unsafe condition. I'm sure that Dave was planning on using tape or screws or some other mechanism to hold it, or tabs. Tracy mentions tabs. Tabs is an element that you can add to the design where you're going to leave a piece of material periodically around here because it knows that it's a cutout piece, and it'll leave those tabs for you to hand cut and do the final separation. Some people leave what they call an onion skin, thin, sometimes that works. So, yeah. But you can preview it and you will catch mistakes here before they hit the machine.
And you will make mistakes that you didn't catch.
You betcha. Okay, last piece of software. It's almost demo time. Machine control software, the last piece. So the last thing that we did after we did our preview in our CAM software was we saved the tool paths as files on our computer. And those tool paths is the script with the G codes that the machine control software will then load and cause the machine, once you've pushed the right buttons, to execute. Excuse me, can I ask you guys to stop? It's a little distracting. Thank you. So the functions of the machine control software, as you can see, is load and run that software. There's a whole thing that goes on about setting the origins, the hardware origins of the machine, reference origins, your workpiece. The tool needs to know where your workpiece is. And that's part of the setup that Dave will take us through so you can see what that looks like. One of the mistakes you might make is, oh, I told the design software the origin was in the middle of my piece of material, but I didn't set the machine up that way. I told it that it's actually the corner of the material. Oops, that's a problem. So
It doesn't know if it's routing error or your part.
no, it doesn't, and it doesn't really care.
Just does what you told it.
Exactly. So I'm going to leave many of the features here because Dave's going to take you through and show you what the machine control software is. I mentioned earlier that Mach 3 is the most popular. It's now been superseded by Mach 4. Some people have moved on. Some people still use Mach 3. This machine uses Mach 3. So you're going to learn the industry standard.
One thing that's important, and for most of you, your machines are going to be in regular inches and so on. I run mine on metric. And so I have to make sure that my machine is turned on, my Mach 3 is turned on in metric.
Yes.
And that my design was done in metric, because especially if I'm importing a piece of software, I mean, a piece of art, and it was set up originally in inches, I have to make sure I converted that, because it will go 30,
Yeah.
but it was only supposed to go 3.
Yes. So Tracy highlights the Hubble telescope problem. Those of you that are familiar with it know that there was a part that was designed in metric that should have been designed in inches. Make sure you use consistent units. And as Tracy highlights, sometimes the clip art comes in with one set of units and the rest of your designs in another. So make sure it's consistent all the way through. Was it? Mars Lander had the problem? G code. We won't get into a lot of detail about G code, fortunately, because we don't have to. The machine understands it. There's lists of hundreds of G codes. Turn on the coolant, turn on the fan, move the thing up, go to home, move over here, cut this thing down. They all have G codes associated with them. And what the G code is, it's a G with a number after it. That's why they call them G codes. And there's a lot of them, and I don't care. But if you need to, the rare opportunity when you want to take a look or need to take a look, you're going to do a quick edit because you understand this shit, more power to you. I have not yet had a need. You ever in any G code?
I know some of the instructions well enough to eliminate them or modify them if I need to.
Okay. Give me an example of when you might need to go in and modify the G code.
Well, one of the things that I do oftentimes is I touch off without the pad. I just touch off the machine. And the software will have an instruction that says, go touch off the bit. I eliminate it. I
Got
just
it.
take
Okay.
out because I just don't want to sit there while it does it.
Okay.
Another one might be, I want to run a piece of the thing over and over again. So there's go-tos and things like that you can put in there. So you can run it
Okay.
over and over, things like that.
Okay.
So you learn to do it.
Okay.
And we'll take a couple of those. You know, it just tells you, for example, right here. It says, go to X1, X equals 1.8657, where it was before, it was 1.9302. So the X-axis, the bit is going to travel from 19302 to 18657, while the Y is moving from 28475 to 2.9. So in other words, it doesn't have to be right angles. It
Yes,
travels point to point.
right.
And this just tells you from this point to this point, from this point to this point. And depending upon what your shape is you're trying to do, it's a very, very nice circle, for example, by making a whole bunch of little steps.
Right, right. All vectors. It all comes down to vectors. And that's what these are. These are 2D vectors, but there's of course 3D vectors as well. You can move in X, Y, and Z simultaneously.
And G code is text.
Yes, it's text. You open it up in Notepad on your Windows machine. But Vince,
There's one command for a whole circle in G code.
there is.
Or in R.
Okay, all right. Okay.
And that F15 is the feed rate.
Is the feed rate?
Yes.
Thank you. Okay. Vince is demonstrating the fact that he can read G code. Why are we not surprised?
And that is on the test.
Yeah, it is on the test. You won't get your green card if you, okay. Okay. One last thing, and then we're going to turn it over to Dave. He's going to talk about how he holds down his work. There's lots of different techniques. We alluded to some of them earlier. I've become kind of a fan of the double-sided sticky tape. It's worked for me. I've only had one failure when I didn't dust off my spoil board, so I didn't get good sticky. This is my Rockler clamp. Notice the etching on the side. One of the things that you see on preview is where the tool will start, and then it zips across to where it's going to start cutting. So if you remember that preview, you won't put your clamp in that path. You can say, go way up here and then come over and come down, but that takes so long. You just want the fastest path. I could show you the clamp that Dave etched on my machine too, but I didn't want to embarrass him, and this one's effective enough. So keep your clamps out of your tool path. The workpiece must be held securely or else. And it also must be flat to the gantry, especially if you're doing particular carving. Sometimes we all know wood tends to warp. You got to either clamp it down really good or give it a surface planing to make sure that you get good consistency, or what the technique that Dave called touch off. Touch off is the procedure by which the machine knows where the material is, the top of the material for the tip of the bit, right? And that 0 point, that touch off point is really important. If you've got a warped piece of wood, that surface is going to change. So you've either got to flatten it out or readjust your touch off point so that your carving is to the proper depth. The other thing that happens, you also need to align your piece of work properly, so that if you have a line that goes all the way across the x-axis and you expect it to be parallel with one of the edges of your piece of work, you got to make sure that you mount your piece of work so that that works. Sometimes also you take off a piece of work and you put it back on, and you have to reestablish those origins to make sure that where you pick up the work is where you left it off. All techniques that Vince is going to take care of for you in the operating class. Time for Dave's demo.
And at this point, I was going to declare a short break because I need to put that on there and make sure I've looked up. So
Awesome.
it'll take me 5 minutes to set that.
Let's take a 5-minute break.
Well, you mean to clean it up? Yeah, maybe we do. Yeah, that's a good idea. We got a festival out there.
Here you go, Dave.
I don't want to be heard.
You don't want to be heard?
No, that works.
Me too. Bland, can I pull the cord out of my laptop?
We're done with it.
It's going to come back,
He's coming back. Oh, yeah, yeah, yeah.
but okay, all right.
But you know, people don't know that. No, it's funny. It's the same kind of thing, though. You got the saw now. It can be.
I've done something.
Yeah. Well, it's a lot different with doing a five operation than it is a 14 or 22. The tiny little magnification and
That's where I got pretty good.
well, the one that I used to use, that my dad used to use, so it's time to find it. I tell people that it's just like chainsaw. You don't have to, you take it back. Change the center, but you're using it, you give it some licks to bring it down. One of the things I tell students is that I think of it like going in college, I don't sharpen, just like chip to polish. And when I was in that city, I was never a color. Quality. I bought it. Well, I'm trying to teach them my language. I love. He's coming back for some. Without saying, well, now I got my shirt here, I got my
Okay, boys and girls, let's get started.
Anyway, he was a guy.
That's your mic on?
So, wasn't available anymore.
What mic?
All right. Okay. One comment is
many of you are well beyond this level with CNC and design work. What we're trying to do is to put together a class for new people to teach them. And so what we're looking for is your feedback as much as anything else. And everything we do, there are various techniques that you can use to do them, in different ones. One of you might be sitting here saying, well, I wouldn't do it that way. That's okay. It's whatever you feel comfortable with in doing it. So what I'd hope to do is to carve a very simple sign for you. But in the process of doing a prototype, I broke the key bit that makes it work. So we are going to carve a sign, but we're going to carve elements of the sign. So fairly quickly, what I'm going to basically show you is the CAD side, which is represented with this set of tools over here, and the CAM side, which converts your drawing pieces into what we call tool paths. And a tool path might be as simple as something as carve from point A to point B, or do a circle as Vince suggested, or carve out a letter or whatever it is. So you're creating a tool path with these tools over here, which then get converted into the G code that gets sent over to the CNC. So fairly quickly, and I'm not controlling this very tightly, set of tools. You've got certain file operations. You can go in and set up your X, Y, and Z. So up here, it says, okay, the width of this particular material, the height of the material, and the thickness of the material, those are important to know, because if you're going to carve down toward the bottom.
Yeah, go ahead. Because I can't do you in a picture.
Thank goodness. So anyway, it's important, depending upon the kind of work you're going to do on your piece, that you know those elements. And we'll need to reset them for this particular one. Throw me a tape measure, would you please, Gary? This is the precise one?
Absolutely.
Okay.
As good as it gets.
That's a woodworker's tape measure.
Okay. So we'll change, for example, the parameters. I had 15. So it's really 14. And the height, hello. And the height, not 10 inches, but 7 1/4. And the thickness is 3/4. So you notice all of a sudden my drawing no longer fits. We'll have to scale it accordingly. See the little tabs up here, you can grab them and make it a little smaller. There's a tool in here that says, okay, I want to center all this on the middle of my workpiece. Now, Richard also mentioned earlier that you need to tell the system where the origin of your work is going to be. Two places are very common. One is in the center of the piece. The other is at a position typically at the lower left-hand corner where X and Y cross at 0. And for this particular one, this is going to be our origin. Okay, that translates.
Would it be helpful to explain that the blurry outline is actually a 3D shape?
We're going to do that.
Oh, you know it.
Yeah. So that translates to the board and this corner right here. Okay, the other thing you can do is you can say, I want to look at it. I want to. What the heck? And you can say, okay, we've got the X and the Y defined, but we also want to know whether we're going to reference the top of the workpiece or the bottom of the workpiece. And that's done here, Z0 position, material surface, or machine bed.
Okay, question, since that board could be anywhere on your spoil board, how do you tell it where that corner is?
We'll do that in a minute. So right now we're doing the design work. And if I tell it wrong over there, all kinds of funny things happen. We make plenty of sawdust. And there are other things you can do. For example, you may want to have your X0, Y0 in here so you can do an offset, things like that. You can scale it. There are a lot of things you can do in the setup.
I can't read that, Dave. Did you have it set to the top of the board? Is that where you're?
Yes, I'm sorry.
That's where you're
Zero
at?
position material surface,
Yeah.
the top of the board.
Now, this is the design of the toolpath at this point?
Right now, what I'm doing is setting up the parameters that tell Aspire in this case, what the target looks like. Okay, and as was pointed out, I have to also go over there and pick the X, Y, and Z spot, and we'll do that. Okay, so we've got that set up. And this thing is called job setup, so that's up there. Okay. Then the next thing you want to do is start actually doing your design. And there are very simple elements that we have on this. We have a couple of ellipses and we have some text, very simple. To do an ellipse, that tool right there draws from the center. You can shape it, play with it, do whatever you want. And if you can also go in and enter the parameters here. For example, I could say, I want that to be at 0, 0 and apply it. And the ellipse is centered at our 0, 0 position. So you can do things like that. I often use the center of the workpiece as the 0, 0 because that way I can center it. But there is a tool in your CAD package called alignment. And you can say align whatever you got highlighted to the center of the board. Boom. So that puts it right there in the middle. So you can do your ellipses. And in a minute, we'll come back around to what we do with those things. Whoopsie. Come on, go away. There we go. Good. So we've drawn a couple of ellipses. We've put some text in it. And as was raised over here, what is this gray area in the middle? Well, what we did is we created a little bit of a model. If you remember Richard's images of this thing in another iteration, there was one where there was sort of a dish carved out and the letters were stood out proud in that dish. So what this gray area is a model of the dish. So these tabs here, there's a drawing tab, which has these tools. You can go in and model something. You can create layers, as many as you need so that you can simplify your overall design. You can expose them or not. There's clip art you can put in there, and you can do multiple sheets. So you might have a cribbage board and you're looking at the top of the cribbage board. Next, you're going to look at the bottom of the cribbage board. You might have something else for doing. No, you don't. And you might have something else for doing the inlays, if you're doing inlays into the board and things like that. This is a fairly new feature in Aspire, and it really is quite helpful. Okay, let's get back to the modeling for just a quick second.
Is it significantly different than the V-Carve or V-Carve Pro? I assume it is. That's why you paid more for it.
Yes, there are things I wanted to do that V-Carve didn't do for me. And so I bit the bullet.
The money.
Yeah,
The tool do what you want it to do.
exactly. So what I'm going to do is very quickly put together yet another ellipse, and I'm just going to put it up here. And what I want to do is create that dish that we talked about. I'm going to go into modeling. And I'm going to very quickly choose Anybody read that? Come on. All right, create a shape. And so there are various shapes you can do. You can do peaks, you can do coves, you can do roundovers, you can do sort of an arc. And I'm going to do a very simple dish shape. Dish would be, hello. There we go. So this one is makes it a convex. This makes it a concave shape. I can define the angle of the slope, if you will. I'll just do it around there. And there is that gray area we talked about before. I can apply it and close it. And then later, when I go into my cam side, it will take that shape and carve it out.
So you define the top and bottom of that shape, how thick that actual curve will be?
I'm sorry, what was the question?
You're making a slope. How do you define the height of that curve?
Good question.
Yeah, where's that at?
The question was, how do I define the height of the slope? And if I go back in here, there's a place for the base height and the overall height here. And as you define the slope, you see it change a little bit there. Yeah. And what that does is it determines how quickly the slope goes down to the full depth. Okay.
So it
So,
doesn't set the depth. It says how fast it's going to get to that depth.
no, it will set the depth. Yeah, oh yeah, you can go in there and you can say, I want this to go to start at a certain height, starting a base height and the depth that you want it to carve. So you can do those things as well. And what I typically do in situations like that, come on. There we go. What I typically try to do is create a very shallow dish that just tops out and smoothly transitions to the surface in situations like that. Now, there are a million things you can do in the drawing side. You can do common shapes, you can do stars, hearts, things like that. But you can combine shapes, you can rotate shapes, you can invert shapes. Extraordinary number of things you can do. Aspire has a very powerful drawing. Set. And the best thing to do is take the VCarve Pro and just play with it. Just draw things until you get what you're looking
These
for.
simple things you're showing us, Dave, are in the VCarve and VCarve Pro too, though, right?
Yes.
This is not sophisticated of where
No.
Aspire takes over.
Right. So let's say I have defined what I want, very simple. This line will be the cutout. This line will be the dish. There's the text we're going to put in it. And that's all we're going to do. So what we can do is we can say, all right, we're in the CAD side. Let's go over to the CAM side and create those tool paths. And I've done those for you, but I'll do them again. So for example, so you notice this big oval out here?
From the earlier version before you shrink it.
That's right. So I can recalculate each of these. So I can double click on it, calculate it. Now it's sized to the material. Or there's a tool up here that I can just go recalculate them all. There we go.
Was that red line up there from your origin to the starting point or something? There was a diagonal red line on there.
It went from here?
Yeah.
Yes. So as Richard mentioned, it will tell you the path of your bit when it's not cutting as well. So if you happen to have a clamp or something on there, I broke my bit because I ignored that. I was in a kind of taking some shortcuts and
Expensive lesson.
yeah,
And then like the bottom profile of the letters is just based on whether you get a V bit or a curve.
and we'll do that right now. So one thing we can do is we can say, all right, here's the profile. I'm going to go in and I'm going to, hello, and I'm going to preview it. So what I was using here is let's go into the profile here. I went a little too quickly there. So what I chose to use to create that shape is an OG bit. So it creates the OG shape. You can do it with round over bits, ball nose bits. Just takes a lot of steps to do it. So there's great form shape bits that you can use to do that. We'll leave it as is. And we'll go to the next one. And now we're talking about a cutout profile. So I've made my shape. And I want to cut out in this hollow here so that all I have left is the board and the border. I'm cutting all the rest of this away. So if I preview that, if I find my there we go. Preview that. It's supposed to cut all the way through. Let's preview that one. There we go. Okay, so you notice the blue background coming through. So I've cut through the material. Now, earlier I mentioned that you can tend to start from the top of the board or the bottom of the board. If you're doing a lot of through cutting, you typically want to start at the bottom of the board so your bit doesn't go below that and cut into your spoil board. I've cut into the spoil board hundreds of times, and then another thing you can do is you can say, all right, now I've got, come on, there you are. Now I've got my shape. I'm going to eliminate the excess material and I'm going to start looking at it. And that's kind of what I'm trying to accomplish. Okay, and you can actually go to specific settings up here. You can look at it from that perspective, from the top, from the front, from the side, and so forth. Now,
before you eliminate that exterior, it showed that profile on both sides because you're using an OG bit. So
it cuts both ways, right? Absolutely. And believe me, many times I've saved the cutoffs just because they're cool. All right.
The picture frame ready to go.
Right. So the other thing I'm going to do now is I'm going to cut that dish. And I've already calculated. I'll just recalculate it here. All right. And I'll preview that. Now this is using the bit that I busted. Okay. So here's the shape. I didn't make a correction for the bit. The Richard shows up there because it was inside of that model when I created it. If I go back over, if I can get there.
That's a separate operation, the lettering.
Yes. Well, no, you really, for this particular example, I want it to be there.
You got to dish around it.
Yeah, so you want to dish around it and have it stand proud. But the other thing we can do, which is what I was going to actually, pardon me?
Centering the text.
Yes. Does, doesn't it?
Just need to recount them.
Something wasn't calculated.
Oh, yeah, another remnant of the earlier bigger version.
Come on. Okay. So I'm going to reset my preview. And what I want to do now is show a different effect of that text, which is a V-carve, which uses a V-bit, one of those red ones that Richard showed you up there. And in this case, we're using a 60-degree V-bit. And if we calculate that, and reset the preview and preview it. Oops. Sorry. Okay, that's not what I intended to do, but it's an interesting one. This thing cut the entire dish with that 60-degree bit. Would have taken hours to cut it, but it left the Richard because it was what a V-carve does, it cuts between lines. And so the outer line was the perimeter of the ellipse and the inner line was the perimeter of each letter or the, okay. So if I reset that again, come on, finding them, there we go. And that happened because you see I had the dish selected at the same time. So if I remove that and then recalculate it,
Wait a minute, how did the recovery? Oh,
oh, I know how.
you need to remove the selection after you.
After I've selected, yeah, there we go. Come on, there we go. Now calculate it. And we'll get to just the Richard and it V-carves the Richard. And you notice the depth here is relatively deep.
It automatically knows where the bottom of the dish is going to be and carves the letters to that.
Yes, what you would do if you were doing it in the dish, you have a selection down here that says project toolpath onto 3D model. So if it knows there was a dish there, and that's what that did. If I take that off and recalculate it and erase it and carve it, it's just going to do the normal Richard. Okay. Had I done both of them and put that back to project, calculate, and I'm going to do both of those tool paths. I'm going to reset and preview the visible ones. Then I'm going to get my dish and the Richard raised and that sort of thing. Hello. I got that Richard in the dish for some reason. I got to get rid of it, but anyway.
It's dropped down again. too.
Yeah. Well, the original one is. It's in the component over here, and I'm too befuddled to figure out how to do it. So I'm not going to worry too much about that right now.
Yeah, you're having trouble even seeing your mouse.
Yeah.
That far away from it.
In theory, that should have eliminated it right there just by taking it out of the equation. All right, let's select this. And then calculate it. Huh, why did it do that? Oh, let's not worry about it now. We don't have time to mess with it. Okay, let's go over to the other side. Let's say we have a very simple thing we're going to do. out of the many steps. We're just going to do the V-carve. We're going to do it without the dish for now until I figure out what that's going on. Not going to project it, recalculate it, and all we're going to get is get the mouse to cooperate. There we go. There we go. That's all we're going to do. So over here, what we, to your question earlier, was, okay, how do we tell the system that we're aligned to what it's done? So, well, look at that. That's nice. What I typically do is I use something like dowels that I put holes in the spoil board that are parallel with the travel of the spindle. And that way I know that whatever I cut is going to be aligned to this edge. And at the risk of being in the way quickly, what we have is keyboard shortcuts for moving or not. I need to get into mock.
Oh,
All right, now you can, I think you can go back. Yeah. So we have keyboard shortcuts for moving the y-axis, the x-axis, and the z. So what I'm trying to do is get the center of the bit aligned with this. Now, in order to do this particular one, I'm going to use a V-carve bit. So forgive me for just a moment while I find the, okay, nobody leave the room. Huh. Our no, that's a little bit. The clamps are missing. The wrenches. They may be. Huh. There was a box that they were in before. Maybe it's over on the other side. I don't think it's locked. All right, we'll just do it with this for now. So what you want to do is get as close to, so you can see it. And you notice the center of the bit has to line up with this edge to do it right. And your control is either continuous or you can step it. I need to go back to mock for a second. All right, mouse, where are you? There we go. So I'm going to do it in, well, it should be hundredths of an inch step jog. And I'm,
You can set the step sizes.
yeah, so I've set it at 1/100 of an inch. And for some reason, the key isn't. I've lost control.
is your keyboard connected to your computer?
Maybe.
Maybe the keys work on any of the keys on the keyboard. You lost connection to the keyboard to the.
That's fun. But see, I've also lost control with mock. Mock is not communicating with it right now.
So you manually find that.
Okay. So basically you can move it continuously or step it and get it so that you're right at the corner. Once you've done that, then you go, there they are. Once you've done that, You say, that's my X0, Y0. You have to go up here and tell Mach, I have no control. I don't know what's going on.
Tell you what I'd like to do. I'd like to continue with the presentation,
I think you're right.
because I have more to do, and you can spend some time getting that set up.
No, I don't think it's gonna, we've got a problem connecting with Mach right now. So we'll have to make that smoother. All right.
Is that all right with you guys?
Anybody wants to
So
speak?
when that board can go anywhere on the spoil board because you're telling the thing where that corner is.
What I'm saying is my reference point for the project that I'm doing is right there.
Right, but it could be, that part could be anywhere on the spoil board because you're manually setting where that 0 is.
Exactly, exactly.
And two things, okay, there are machine coordinates. That's the absolute coordinate for the machine. There's the job coordinate, which is what he's trying to separate now, the job coordinate, where the zero is.
Physical space.
No,
Gonna have to talk really loud.
Okay. On with the show. What I'd like to show you now, you've just experienced some of the challenges of CNC.
See, we just leap right into his presentation.
It can be a little complicated. It can be a little fiddly. The design part can be a little fiddly. The execution part can be a little fiddly. And it's true that even experienced folks sometimes get a little fiddly. We'll have to add another rite of passage. But we talked a couple about this is what I wanted it to look like. So you got problems with your design. Dave talked about what happens if you mismatch your origins. Let's say you told the design software it's the top of the workpiece. And then when you set up Mach, you said, no, I meant the bottom of the workpiece. You're going to drill a hole in your spoil board. It happens. You picked the wrong tool. In my system, I have to, when I do the design, I have to say tool number 6 is my V-bit tool. And that number 6 bit better match what bit number 6 is in my machine control software, or I'm going to be cutting with the wrong bit. Been there, done that.
You assign the numbers to whatever bit you.
Correct. I assign the numbers in my machine software, and then I have to select that proper number in my design software. I have the gouge in my spoil board to show you where I did not do that. You can break bits. I haven't done it yet, but Dave has broken at least 3 since I've, all right, never mind. You can cut into clamps. We showed you the picture of that. And you're
Bits from like too fast a feed rate from too small a bit.
Putting the bit where it has no business being.
Hitting something.
yeah, clamps or right or
Then it wants to move.
yeah, right. No, right.
But starting up too fast is another way of, busting a bit. If you're dealing with a 16th inch bit and you're going to go at 40 inches a minute, well, if you're going to hit something solid, it's going to break.
Okay. All right. Here's my favorite part of the presentation. I can tell it's a 8:45. I can tell you we're going to run a little late. I'm hoping about 9:15. So those of you that are planning your time, plan it accordingly. When I was putting the presentation together, I asked the guild members on the CNC SIG mailing list, be famous, send me some pictures of work. I got 10 people to send me work. I'm honored. So let me show you what you guys have done. First, me. Dave laughs because he knows that as of 2 weeks ago, I didn't have bupkis to show anybody. And I asked for some background for some folks and a little bit about how they were cut. So I'm a novice woodworker. and I have 1 month of CNC experience. I happened to tell a couple of friends, CNC, and they said, I got this daughter. She's got this quote. It's her birthday. I don't want her to get the tattoo. Can you make her a sign? Okay. Seemed like I'm telling you, that bumphead parrotfish thing, that was going to take me a while. So I'm glad I got something a little simpler. So this is what I made. And so the quote is, feet, why do I need you when I have wings to fly? Hence the butterfly is also one of her favorite little creatures.
You
So
do know a couple of those are moths, right?
a couple of those are moths. Shh. No, I didn't know. Thanks. You're ruining it. Tracy Ann is pointing out that a couple of those are moths and not butterflies. Okay. So, okay, so they're moths. They have wings though, don't they? Moths do. So the frame I actually created myself with a rectangle and 2 ellipses, and then welding the things together and using the scale command to make one bigger than the next. I used the V-carve to cut the letters, and you can see they're filled in. I painted the black. There's a couple of techniques for doing that. One is you shellac the surface first, then carve, then paint, then sand the shellac off, and the paint doesn't bleed in through the shellac. You get nice crisp lines. Or you can use ore mask. It's vinyl. That's Ed's preferred technique. Basically does the same thing that the shellac layer does.
That's a fantastic first attempt.
Thank you very much.
That's your very first project?
That is my very first project. Yeah, you didn't say it was very nice. By the way, those of you on Zoom, I'm talking to Dave. Yes, he did. He even took me to dinner to celebrate. It was awesome. So that's what I made. Thank you very much. This is what I also made. Now, none of the other members sent me any of this stuff, but I guarantee you they've all got stuff like this laying around in the shop. Exactly, exactly.
For those of you that have more experience, do you always do a physical test cut?
Yeah, you'd have to ask somebody with more experience.
Not necessarily,
No, you'll just go for it.
but then again, I make mistakes. So,
Yeah, Vince, you don't, you just go for it.
well, Vince is.
Mostly I do not do test cuts.
Okay, that's what, Tracy,
For this clock,
yes,
I did that in a glue up of chipboard. I used three
Ah.
pieces to glue that up
Yep.
because that was, yeah, that's a piece of walnut I did not want to part with.
right, yeah. So Tracy cut walnut and used some chipboard as a test. I had some MDF, and that's what I used.
And the real reason why is because I had to do the back.
Oh my, yes, the back of her clock is carved out as well.
For the thickness.
Yeah, yeah,
I'll sometimes run it without the router bit in.
yes.
Make sure it's going in the right places.
Yes, the Mark brought up the technique called an airproof, where you just run the router around without a bit and see what happens. A good technique.
Now, interestingly enough, this lower left-hand corner one, pretty good prototype, probably not the first one before. But you notice the butterflies and the moths are a little too deeply carved. So
Right.
running it once, you get a sense for all those things.
Yeah, what depth is, it's my sense of depth in adjusting all of this took some experience to get it right. And-
My guess is those are what, 200s or 100s?
Yeah, something like that. Yeah, not very much. And the holes in the upper right-hand corner, that was when I was having problems with my Z gantry. And so, yeah. All right, so that's me. Let's talk about Tracy and her little wood shop. So Tracy sent in a number of photos, and for those of you here, you'll have the opportunity to see a number of these pieces of work in person. When she got started, she started doing this walnut, Petric, clip art, beautiful work with end mills and tapered ball nose bits in order to get that fine detail. Then she progressed. And I like the way when she took her photographs, she also included the bits that she used so you can get a feel for what that is. This guy on the right-hand side is the keyhole bit that she used to carve the keyhole in the back to hang the item up.
And the little one is for my logo.
Ah, the little one's for the logo. Logo's on the back. Cool. Tracy getting fancy. Black walnut. This is the clock that she has here. In person, it's stunning. How long did it take to cut this?
A week.
A week to cut the clock. How thick is it? An inch? Inch and a half.
The original was 49 millimeters.
Okay.
So I work everything in metric.
Just short of 2 inches. Yeah, nice, beautiful. And then this one also present here. Eagle, hawk? Help me.
Eagle?
Not a moth. Eagle,
No, it's not a moth.
not a moth. Got it. Okay.
I started this one off because of how thick it was. I used
Yeah.
to half it. I did 2 roughing passes. So the first roughing pass was with a half inch. Because I have a lot to do.
Yep.
And then I came back with a 1/4 inch.
Yeah, that's a pretty honking bit in the world of CNC.
Now, the background, that finish is right off the machine, or do you have to sand that to get that smooth?
That's why I run the bit that 16th inch at only 8% step over.
Understand step over? Here's the bit and it makes a pass. And then it's going to make another pass. How far over does it go?
8% of the 16th of an inch.
Yes.
Eight,
So that's why
right.
it's so raw. But I
That-
don't have to sand
So then that
Right.
is right off the machine.
Yeah,
well, yeah, and I do a really rough sanding with a real fine 500 grit.
yeah. There's usually some fuzzies. Sometimes there's fuzzies, mops or something will take them off. I did a little bit more sanding on my work. But-
Also, if you were to do a bigger step over, let's say like a 10%, 12%, you're gonna see lines through.
Yep.
because it's not gonna clean
Yeah.
that up. That's why you have to do that.
Tracy speaking to the advantage of getting this stunning detail by using small step over gaps. Okay, thank you very much, Tracy. And again, we'll have the opportunity to see some of the finished work here in person. Craig, head of the SIG, brought some stuff in. He's got years of experience and he tells us that he bought the logo that he put in. You can notice that he's got painted as well, red and black painted. The rope border done with clip art. Cool. Nice work. But here's some really stunning pieces. 50th anniversary piece that he cut, I'm imagining for Kathleen. Okay. And also working not only in wood, but in acrylic, multiple layers to get the colors, and then a base with light in it in order to edge light the acrylic. Yes, and one of Craig's signs has been gracing the bench room here for quite some time. Beautiful work.
Unlighted version. Well,
Yep.
actually, it will light up.
As an example of what can be done on a rotary axis, Craig brought in actually to the room a cane that he turned with a clever handle, as you can imagine, for a woodworker. How long is it? About 3 feet?
Yeah, it could be whatever length you want.
Huh?
I don't know.
So what
Yeah.
it really shows is that even for CNC work, a hammer is an essential tool.
Ah, ooh, good one. Dave says, I'm not, if you heard in the peanut gallery.
I think this was a multifunctional tool because, you can use it as a cane.
Yeah.
And then if people get out of line.
Ah, yeah, if you had a hammer. Okay, Mark submitted. Thank you, Craig, very much for the work that you submitted. Mark, as you can see, is an amateur woodworker, but has a lot of experience. He's been remodeling his home, requires a lot of work. He talked to me a little bit earlier about some of the other stuff that he's doing. He's relatively new to CNC, and he's got one of them, their Chinese machines. And I think what I heard was you weren't really recommending it for other folks?
I would, if I had it to do over again, I would probably buy a different machine, but I got it for free.
Ah, yep, right. So he got it for the right price, which was free, and it's certainly been serving the purpose. He's been working on, in this particular project, working on railings here and more in the back, using Fusion 360 to do it. The pails are the pieces, of course, in the rail. Made 200 of them. And you can see that with a jig, he's able to cut 4 of them at a time, 15 minutes a piece. Here's what the design looked like in Fusion 360. Really nice work. 15 minutes, bing, bang, boom. None of that fancy detail stuff. You mentioned what kind of bit you're using? Yeah.
That was make pitch, just flat bottom.
Yep. Yep.
What was the thickness of the material?
It's 4/4, so it's 3/4 of an inch.
Yep. 3/4 of an inch thick material.
Yeah, 3/4 inch vertical grain fur.
Yeah. Awesome. Okay. Bill Cogswell, who I believe may still be on the Zoom call. Bill sent in a number of pieces as well. Calls himself a semi-professional, a lot of woodworking experience and a little bit of CAD experience using Carbide 3D, which suggests that he's running on a Shapeco.
That's true.
In this case, he said the design elements that he got, the image came from the client that requested it, and he cut it all with a 90-degree V-bit. 90-degree, of course, is the profile of the bit. And he said it took about an hour to cut it. He also did some work in laminate, right? You got the 2-color laminate stuff. So when you cut through, you get the background color to come through. Clever technique. Also done in Carbide 3D, also using a 90-degree V-bit, quick to cut. Many of you that may know Bill, he is the founder of the Olympia Woodworkers Guild and still participates in stuff with us down here as well. One of the pieces that Bill submitted is called a needle minder. My wife, I got everybody know Ned needle minder from Groundhog Day? Never mind. Thank you. All right, but it sounds like needle minder. That was my best joke of the night. Gee, man, I guess. All right, never mind. So he made it out of maple. So the idea is this holds needles, right? Sewing needles. So he's got a magnet sandwiched in between a couple of pieces of wood. Same on Carbide 3D, still 90-degree V-bit. And then to get that detail using a 1/32 bit, that's a pretty fine end mill bit to cut. And it only took him 10 minutes. Bill, thank you very much for what you
You're welcome.
I heard that, Dave. Thank you.
I was trying to get him up there, but I can't.
Bill, thank you. Got it. Dave is our pro, been doing this for a decade, makes all kinds of custom game boards. He's got a wonderful website that I actually had discovered when I was browsing around on the web months before I got to meet Dave. VancouverWoodsmith.com. I was up in Vancouver, went to Austin, came back, member of the guild, just lives down the hall, is doing all kinds of great stuff. And he makes custom game boards. And this is an example of the Scrabble board. I got the pleasure of having him drill through his Scrabble board a couple of times on my machine as we debugged it. And then he actually did some useful work too. Beautiful stuff. How about that Monopoly board? How do you paint that?
You know, you talked about, you shellac it, you rub the gold or whatever color you're using in, and then you wipe it off or sand it off.
Okay, so similar technique that I described earlier, Dave says, for getting the color in there, shellac, paint, sand it off. Love the detail on that. It's just wonderful. And speaking about drilling holes, you count them if you want. 2-player boards, 4-player boards have twice as many holes. You can get up to a couple of hundred holes. And in addition to all the drilling patterns, of course, is the inlay work that was done. And I understand it inlaid with bamboo. Inlaid with bamboo.
Well, no, the board itself is bamboo. The inlay is maple and can be maple.
Thank you.
And this one is all maple.
So maple bamboo board and inlaid work. And you use the inlay command in VCarve to do,
Command to create the pocket and the inlay.
yep, sandwich them together. Very cool. Very cool. Clip art, your design?
The Pelican was a piece of clip art.
Ah, okay.
All the rest of it, well, the whale was too.
Yeah.
The whale is actually not done with V-carve, it's done with a vertical side. And it stands proud of the board, and then I carve the surface of the whale into the maple, so
Wow,
it stands up.
nice. Okay, so the whale is proud of the board. Very nice. Okay. Thank you very much, Dave. John, I hope Cloper, anybody know how to pronounce his name correctly? Thank you, John K. Also beautiful inlaid box. His wife has been doing these sketches that she calls warm fuzzies for the kids and family for years. John grabbed one of the napkins that had one of these sketches on it, scanned it in again, and used Carbide Create, again, suggesting Shapeco, and did the inlay work using the 60-degree V carving bit. Just beautiful. Thank you, John, very much for your contributions. Vince, I didn't have a bio for you.
Oh, okay. I did this for a client. He gave me a general drawing and I developed a pattern and cut it out on a bunch of pieces. He used these in building some tables for a church.
Got it. Church tables. And Vince, at least a decade of CNC experience. How much?
A lot of woodworking experience in 2 years of CNC.
Just 2 years of CNC and a lot of woodworking.
Well,
Yep.
a lot of software and physics.
Yes, yes. So he's got the geeky background, and I had the pleasure of going to his house and shop, and the house is filled with spectacular furniture that Vince has made. It's just beautiful work. This is one of the things that I think is most clever because it speaks to my interest in joinery on the CNC. Double mortise and tenons is not the easiest thing to do by hand, but as you can see in the right-hand photo, Vince can pop them out like popcorn. It's just amazing.
Yeah, they need to fit just right.
They need to fit just right in a repeatable kind of way. What was and what were these elements included in? What was the project?
What?
What did you use these joints in?
A client part, a little T part that slides around in a groove for a product.
Okay. All right. Thank you. But wait, there's more. Vince is blessed to have a 3x5 machine that's big enough to be able to do sheet goods.
So I have another client. This is 1/2-inch Baltic birch, and I cut these parts out and stain them black. They're used in a product in Hillsborough.
Huh. Okay.
So every few months he orders a couple hundred.
Nice client.
Yeah.
Makes hundreds of them. And how many in a board? I didn't count. 1, 2, 3, 4, 5, a dozen, looks like.
I can make 16 over in this 35 by 60 sheet.
Wow.
And it has holes with countersinks as well as some very specific contours.
Yeah.
So that's one of the things that Vince does a lot of and is a significant value when you've got CNC. If you were to make a cabinet or anything like that using a saw, drills and routers and that sort of thing, it would take you an incredible amount of time. Whereas here, you do it all in one operation. The only work you have to do, you don't have an automatic changer. You have to change the bit, of course, for each tool path.
Right.
But the parts come out and they fit together every time.
Right.
One little thing, the little notch on the contour has to be within 10,000ths of an inch. So anyway, no problem if you program it right.
No problem. So 10,000ths of an inch, a lot of repeatability, only one setup other than tool changes, lay a sheet down, 16 pieces come out at the end, done.
Go back up one slide for a
2
second.
minutes left on the recorder.
Oh my,
On this.
okay. I'm gonna go really fast. All right.
Can you go back one slide? Yeah, here. Talk about mitering pieces. You cut that with a 90-degree bit, right?
Yes, I cut that with a 90-degree bit.
bit, right,
Just go together.
right,
Yeah,
nice. So I hear that we have 2 minutes left on the recording.
Say goodnight.
What I'm gonna do is I'm gonna skip to the end, do a summary, and then come back and do some more of these. So we get the summary on the, because there's some beautiful stuff to be done here. So takeaway, amazingly talented. You've already seen some, you'll see more. One of the best parts about the Guild is the talent and the sharing and the community that we have here. And we're building that now around CNC expertise. And I think it's fantastic. So thank you for that. You'll see, if we haven't already seen, examples of using it, CNC, for embellishment, using it for the repetition, using it for the precision, the joinery work, using it either to make components or the entire piece, finished piece is produced on CNC. It's the combination of the right software features, and the right capabilities of your machine that make that happen. And as was pointed out a little bit earlier, there's a lot of overlap between CNC and 3D printing. A lot of the design work is the same. The cam and the machine is different, of course, but a lot of the thought processes are similar. What's happening next at the Guild? We're going to get the router installed in the studio. When the studio gets up, we're going to use it primarily for education. You've already heard about the new machine. We're going to turn this pilot class into an official class. Vince is going to teach the follow-on class about how to do this, operations and safety. Then there's a mentor program that's going to be specialized shop attendants that are going to give you, once you've been through these classes, access to the machine with supervision, and guys like these that'll help guide you in your project. I can't wait. And there's more classes that we hope to teach specifically around design and specifically around building stuff. I hope that this is the only class we do that isn't hands-on. We want to make stuff. We want classes that help us make stuff. What's next for you? If you haven't yet joined the SIG, join the SIG. Come to the monthly meetings. We're going to start holding them face-to-face and hybrid, so that we can meet here again and share work and have a good time together. Download some software and play around with it. If you don't have copies of this stuff yet, you can get free copies of Carbide Create and VCarve, trial version free. You can't cut with it, but all the design features in VCarve that you might want to use are there. There's hundreds of clip art sites. I could give you lists of places to go, but if you don't know how to use Google and search for CNC clip art files, this isn't the right stuff for you. You know what I'm saying? And there's stuff everywhere, YouTube videos that'll train you, Pinterest boards. I mean, the internet is littered with stuff that will help you get going. That's it. So got the recording. And if you, thank you. And if you guys have another couple of minutes, this is what Vince did with his rotary axis. Remember we said there's that thread toolpath? Here it is in action. Go ahead.
this isn't the VCarve thread. This is a legacy thread.
Conversational game.
Yeah, conversational cam, where I both cut it to round and then did the threading and did cut the body for this part. And I had a tap that I used to cut the inside thread.
Wow. Okay. Okay. Yeah, that'd be hard to do.
Okay.
Thank you. So I lied about using Aspire thread. Thank you for the correction. We'll adjust the slide.
Actually, while you have that picture up real quick, the legacy Maverick, this system has 5 axes, not the one where the spindle turns. That's a 6-axis. The fifth axis allows you to raise and lower the end.
Oh, my.
So you can make tapered spindles as well.
Dave is pointing out the fact that the fourth axis here has a vertically adjustable point for doing items like tapered. And Vince tells me that he didn't use the Aspire thread toolpath to do that. So Craig's cane is tapered, and that's how he achieved that effect. Very cool. Made some speaker cabinets.
These are big speaker cabinets for a big church organ. I cut them all out on the CNC. They need to be gap free. Anyway, it's an ideal project.
Ideal project. Yep.
It's particle board.
Yeah, particle board and the whole speaker cabinet, including the joinery, cut on the machine. Yes?
Yep.
Cool. This is my favorite. Edging on the table. Tell me how you did this.
So I did this design in SketchUp, and then I transferred DXF files to VCarve. I cut out the edging, solid wood edging around a veneer covered plywood core. I shot the veneer myself, but it matched up perfectly. There's a process you go through to get all of the joints to be perfect, but the CNC did the hard work. I also cut the legs out of the CNC.
Yeah. Wow. Just remarkable.
So these long ones here are the sides,
The edges, right?
and the short ones up here
Are
are
the
the
corners.
corners.
Ah,
Yeah.
got it.
Thank you.
Yep. Yep.
And that's enough edges for 2 tables. I did 2 tables.
Ah,
Well, the first one was the hard one.
Yeah, right.
The second one was a lot easier for some reason.
Right.
remarkable. So CNC and fine furniture go together. Then there's this project that Vince and Rich Masilis did together, as I understand it. Do I have that right? Because I got some stuff from Rich as well.
Rich designed the concept. I entered it into SketchUp and used Cabinet Sense to actually create the parts.
Okay.
That Cabinet Sense transferred it to VCarve using DXF files. Yeah, that's a picture I haven't seen.
Ah, there you go.
So Richard cut it out on his big machine. That's an automatic tool changer.
Ah, oh, down at the end. Yeah, there's the automatic tool changer.
That's a 4x8 or a 5x12? 4x8.
4x8.
It's a 5x8.
Okay.
Yep. Nice, right? So all the cabinetry cut out. Then,
I wrote a gadget to do dovetails, and I made all his drawers for that case with through dovetails that I cut on the vertical vise on my own machine using my gadget.
and then Rich glued them up.
Rich glued them up, and yes,
That's what he told me.
yep.
All right. Neither of us are lying yet. And then Rich finished the
Yeah.
assembly
He did it all.
and installed it. That's the last photo I've got. So this was, there is the
That's
finished
the
piece of
end
work,
product, yeah.
right? Okay,
Second from the wall.
suspended from the wall. Okay. Yes, plug-in.
Software plugin.
Software plug-in.
Okay. This is Steve McGowan. Steve spends time at Intel and some other stuff. We talked a lot about his history. He uses 3D in his day job. He uses SolidWorks and then transfers stuff into VCarve to do woodworking. He made, he said, 15 different cutting boards, each of which had some schmancy design on the back. This is one of them with the marine compass. And it apparently took a lot of work, 10 files in order to cut it, varying levels, varying depths. So that's one. That's why it's sitting on the stove. It's in the kitchen. Then this one which highlights another technique. As you can see, what he did was he created the rough out on CNC and then hand carved it himself, which I think is, I'm hoping it's the gateway drug for the hand carvers of the guild to come to appreciate what CNC can do. And as I Googled around on doing this, in particular for classes, hand carved classes, where the goal of the class is the detail work, you might spend half the class just doing the rough out before you get to the fun part. What if we could do the rough outs for the class on CNC and then they can just do the fun part? I think that'd be very cool. I'm going to get Ruth to work on that with me. There's also, by the way, a weave command in Aspire. I have another interest in doing Celtic woven knots and things. It will do the under over. It's really cool. Okay, Steve has also done inlay, and here's a good example of how it's done with both sides. And what he said is he used basically the same tool paths, but used different bits. And the difference in the bits created the clearance that he needed in order to make the inlay work. You're familiar with the technique of carving that whole piece, gluing it in, flopping it in, and then sanding off the rest and leaving the letters
So
behind.
The sides of the socket and the sides of the inlay are not vertical. They're typically 60 degrees, sometimes 90 degrees, but 60 is good enough. And that creates a wedge-shaped thing that fits into a wedge-shaped thing.
Right, right. So Dave made the point that cut with V-bits so that you get that around the edges so that you get the socket to put the inlay in. Then Steve spends much of his time doing 3D printing work. And he and some other people like to model these incredibly complex clockworks, most of which he does in 3D printing. But he had a buddy that found his designs. He sells some of his designs or gives them away on the internet, found somebody in France that wanted to do it in wood. And this is the result. So to talk about the overlap between 3D printing and woodwork, this is just astounding work. There was modifications to the design that needed to be done. The two of them collaborated together, but this is the result.
And that actually turns.
And it actually turns. It works. It works. It's remarkable. Thank you, Steve. Appreciate it. Going to his shop is like, the whole house is the shop. It's crazy. The desk, the garage, the 2 rooms, his wife's stuff. That's really cool. Very fun guy. And Steve knows a lot about this stuff. And he's still married. And there we are. Now we're caught up. Ta-da! Da-da-da-da-da-da-da-da-da-da-da.
4 hours of stuff in 3 hours and 20 minutes.
Not bad, right? Not bad. A little bit of feedback about the class. So this is the pre-pilot. We may do a pilot. We may just, I don't know, run the thing out. I want to get something done in September. Good class. Too much, too fast, too slow, too dense. If you don't have any background, it's like, oh my God, really? Give me a little something.
For a totally newbie, it was amazing, but it was a little bit too much material, given it in the same time frame. Because some of us are older, not you, I know, but it takes a while to absorb it. So I would suggest, I mean, the material is all great. I would chop it in 2.
Chop it in 2.
I know everything's integrated and you got or make it 3 sections or something. That would have been more palatable.
Okay.
for me.
Okay. This comes to the crux of the issue for me. I tried to design a 3-hour class. I didn't think anybody would tolerate going longer, just sitting on your ass. It's hard. It's hard. And it's a lot of stuff. There's a lot of concepts. So I didn't know if it was too much. I wanted to go fast enough. I didn't see anybody fall asleep. I thought that was good. I don't like it when people fall asleep.
We pass out no-nos.
Yeah, okay, that helps. But your feedback about maybe, because I think that running it longer, you're just going to sag.
I'm not suggesting that. I'm saying the materials, I mean, this is an excellent presentation,
Thank you.
but it's so much material for a
Yes.
newbie anyways.
Yes.
Split this into 3 sections.
Yes. Okay.
That would have been more palatable.
Got it.
But man, thank you. This really gives you a wonderful flow. what you guys are doing.
Thank you.
From our experience here, I would take the demo part and make it a totally separate sort of a hands-on thing.
Hmm.
So you can go through the material one night, go through an application of it another night. Because it's just,
But
Okay. Vince, you're thinking,
You might combine the demo with the machine operation.
yes. Well, there will be certainly. I guess for me, so the comment is whether the demo should be in this part of the session or not. I thought it'd be great to, if you haven't seen the machine work, to actually see it cut something is pretty cool. It's at least cool for the first 3 minutes, and it's like, Jesus, isn't it done yet? So so we're wrestling with that.
I think to have a little bit early on in the flow.
You'd like to see it cut something? Yeah, I'm seeing nods that we ought to include a demo of some sort.
maybe just cuts it.
Yeah, maybe,
Really simple, yeah,
yeah.
Just set it up and just cut something simple and start.
just one other bit.
And okay,
Because
simple
you
design.
need to explain the abstract concepts like zero stacking and things, which actually with a bit of a demo, it probably makes more sense if you
Okay.
words to
Okay,
cover something.
so 3 or 4 minute of introduction to the demo and then just cut is what I'm hearing.
I think probably you could build them.
Okay.
But it just seems to me-
This is not criticism. This is feedback to help make the class better for the students to come. So thank you.
It's a fine line between, like someone like us who has zero, I mean, I understand the concepts on it. Because when you start talking about programming stuff, I could understand it, but it was, like, is this a true introduction, like, or, it's a fine line between, you start getting all those symbols and when you do your part, that's almost could be in the next.
Yes.
Yeah.
Yeah,
Really, like for me, the next step is the program. I mean, it's really all about programming computers. And guys that know computers and are good at it say, oh, it's easy, but I look at it and it doesn't look easy. And I'm really interested in it, but that's where for CNC, there's 2 levels, or 3. There's introduction, just like here's what it does, here's things you can do with it. Then there's the programming, and then there's the design is like the next level. Just figure out how to get it to work and do what you want. Then you can start talking about design.
Yes.
And how crazy you could get if you wanted to.
Yes.
But just for me to be able to turn it on and make it do a circle or a square, that's like next level. for me.
Right. So I hear you. And the flow that you just described is what it is that we have in mind. I'm not expecting anybody to come away from this class being able to do anything other than download some software and screw around, or come in and watch Dave or somebody else use the machine and ask some questions and watch it work. I think that that's important too.
It
So
wasn't gonna explain the steps though, like, okay, here's what it's gonna take to get to here.
Yes,
I like that.
that calibration we thought was important. And then being able to use the machine safely. That's what Vince's class is about. And after that is the design class, because you're right, even after Vince's operation and safety class, he'll walk through a design, but he's not going to teach you how to design. That's going to be a subsequent
But
class.
the operation safety is somebody that already knows how to program a tool path. Like, I got a long way to go before I even need to turn on the machine. I need a class that shows me how to put
In my
together.
class, I give you the tool. You just learn how to run it.
Right, but I can hit the button, with your tool path, I can go, okay, go and watch it go.
There's a little bit more to it than that.
Well, no, but I mean, to me, the next step is
Okay.
creating the tool path myself.
Yes,
Something simple.
In
yes,
my mind, it's like, what do all those commands mean? What are those tools on the program,
right.
the coordinates?
And the best way to do that is to go download that free copy of VCarve
Right.
and just play with it, because you got the,
Yeah, but I wouldn't even know how to play with it without some instruction.
Okay.
on what any of that means. That's
Okay.
There are a number of YouTubes.
right.
Mark Lindsay has a VCarve.
I understand all that, but I'm talking about class flow. Yeah,
I'm with
if-
you.
If I wanted to, yeah, I can go do it all on my own on YouTube, but if I'm gonna If I'm looking at a class path here, that's my next class that I would want to take here.
So
Otherwise, I'm on my own doing it on YouTube,
Yep.
downloading free stuff and just figuring it out.
So one of the concepts that I have for Vince's class, and allow me to put words in his mouth for a minute, is there's a half a dozen people in the class. It's a 3 or 4 hour class. Each person will get a half an hour of machine time to cut something, but they'll also get some time with the instructor to sit down at the design. And instead of carving a sign that says Richard, maybe you'd rather have a sign that says Mark. And maybe you want it concave, and maybe you want it convex. And you can say, here's what I'm thinking, and then watch how Vince does it. And at least get a feel for what the design process is like that way. Is that?
Yeah, no, that'd be a good class too. I'm just saying, from a complete beginner starting at 0, if you want to put together a class path, like I understand anybody can go on YouTube and do it on their own. Anybody can download the piece
Right.
and do it on their own.
Right.
I'm looking for a class
Yes.
because I'm not a YouTube guy either.
Right.
I mean, I go on YouTube all the time, but you know what I mean? That's not my learning.
Right. And that's why we have in-person education, because
Exactly. So
there's
I'm
more
gonna take a
value there.
class where everyone brings in their computer and we design something.
Do you think that could be done using Zoom?
Yeah, it can be done on Zoom.
Yeah, if everybody had a copy of the software and the Zoom, and we say,
Yeah.
okay, we're gonna do this, now go do it.
And we did that we did a test run for SketchUp like that.
Right.
during COVID.
Right.
SketchUp class runs that way. It's all on
Yeah.
Zoom and everybody's got software.
Yeah, we should think about that. Yeah,
So
that's a good way to get into it without.
It's like going to the gym. I can go look at workouts and go to
Right.
the gym and do it myself, but I belong to a gym where there's an instructor there that says, okay, now we're going to do this, now we're going to do that, you know.
Yep.
That's just the way I do it. So if you're talking about a path from 0 to making stuff, it's not go check it on YouTube, it's a class with me.
Okay.
So when I talked about a sequence of this intro class, whet your appetite, then the operations class, and then design class, you're suggesting do a really basic design class first, so I can make something.
If you call design just learning how to use the software, then yes.
Yes.
I'm not saying, like, to me, design is, I want to create something like this. It's, okay, we're all just going to make a box. or
Right,
make
a
square,
rectangle,
or
right,
carve an oval.
right, right.
Those steps,
Yes, yes, yes.
That's the next. for
Okay,
me,
I get that.
Personally.
I get that.
But if you're gonna talk about an introduction, you need to think about your audience now. Everybody is a retired software engineer.
Right.
You can go like hell on this.
This
stuff.
group is
Right.
pretty.
I would say you need to cut your slides down by about 70%. And just like that one slide you showed with the, pathway, you can spend a lot of time on that. And that really does tell you the pathway to
Yes,
success.
yes.
That one resonated. Well, after that, my mind just started spinning.
Spinning in a good way or spinning in a not so good way?
I was thinking about the weekend. That time. But I'm suggesting though, if you keep it down to your fundamental message for introduction, it's not going to be 3 hours. It's going to be the elements of what you're talking about, the 3 elements getting to that end product of actually cranking the machine on and doing it, which I understand. I'm a retired engineer. This all makes most sense to me, but I still get buzzed out when I see 30 slides when you could do 10.
Okay,
Your presentation is really class. by the way.
thank you,
I would highly suggest
thank you.
presenting stuff, but it's just too much material.
Okay.
Anyways, that's.
Okay.
That I
you-
told
you-
my wife would be irritated at me.
Thank you. I really appreciate your comments. Thank you for coming.
This was a pleasure.
Great, thank you. You weren't the only one who said, this is really dense with information. So that's certainly one of the things I'm taking away is, I wanted to do a good overview. There's a tendency to tell you everything that we know. We don't want to do that. We knew that that'd be too much. But apparently I could be carving away a little bit
You
more.
guys love it too much.
Yeah, got it.
Thank you so
Got
much.
it.
This was great.
Thank you. Thank you. Dude, say something.
Yeah, I was totally agree with what's being said here for what I think you're describing as